We are live. Careful what you say. No, I'm just kidding. Careful what I say. Okay, so moving us along a little bit here. I'll give you the disclaimer that we're recording. We're in CS 5008 and 9, and our course title. This is a huge course title, so I kind of have to break it down a little bit just to understand what class we're in here. Figure we start with that. But we're going to be talking about data structures, so how we store information, retrieve it, why we do it, and what those trade-offs are. Algorithms, which I think most folks have again experienced in 5001 and 2, how we process that data, and pretty much all these topics we're going to look at within the context of computer systems. So how our machine actually works. What is an operating system? What is the hardware in our actual machines? So you're going to get a lot of, or a very wide view in this course. I'll talk about sort of why that is in a little bit. Okay, so computer systems, or sort of starting with a computer systems-y theme here. But another famous figure here, and some words of wisdom. Andy Grove, he says, only the paranoid survive. Ooh, that's a little bit scary. Does anybody know who Andy Grove is? Is anybody from California or Oregon? Might be more prevalent there. Okay. He's one of the founders of Intel, actually. He's a little bit intense here, so we're going to try to have some fun along the way. So there's my sort of wisdom alongside of Andy here. So, just a little bit of the history here. So, one of the founders of Intel. So often when I'm thinking about at least the computer systems part of this course, I'm thinking about Intels, AMDs, Apples, and what made those companies interesting? Why are those the name brands on your machines in front of you? Why do you see I see so many Apples today here. But why do we see them? What do they do? And often, I think about computer systems folks as being very clever because you just understand, how does it work? That's going to be part of what this course is going to be. In fact, if I go to the website, which we'll do a little bit of an introduction to, how to get here and all these logistics, part of our theme is just, no more magic. Just trying to figure out, these machines were created by engineers. They're likely going to be developed further by you folks in the classroom in some way or another. And it's really not magic, but we have to understand what's sort of going on at each of the different layers. It's going to be a little bit like peeling an onion without any crying, hopefully, for anybody who's a cook. All right, so here's some of the key figures. Here's Andy Grove. Here he is, a younger version on the left, and the other founders at Intel. All right, so a little bit about me, your instructor. I got into computer science because I wanted to make games. I wonder how many other folks are here because they want to make games. You can just kind of nod your head. Maybe a few folks. Maybe a few folks are like, no, some yes. But anyway, this is a Google search I did long ago. And then I figured out, you had to do programming, so I had to learn programming and art and learn about art and music and learning instruments and all these different things. That's kind of how I got started. I was interested in games. So you're going to see some of these sort of games and graphics examples pop up. Some of you will see me later on in different courses relating to games and graphics and system stuff. So just a little bit of my history. I started when I was in middle school, sort of writing tutorials and for a magazine, and that was super fun. Sort of a different approach to computer science. So I started off as a sort of technical writer, so not really in the midst of things. But then I decided to go to Ohio State for my undergrad, the Ohio State University. And then, somebody there told me, hey, you can make games and help people and do sort of research. I said, hey, that's kind of cool. So that's how I got involved in research. And someone said, Mike, you should do a PhD. I said, what's a PhD? I had no idea. Eventually sort of went down that path of applying to programs. And I wanted to come to Boston because there were so many great schools here. So we're really the best place in the world to be doing computer science. I don't know what the official ranking is, but I think Northeastern's 13 or 14 overall. So we're in a really good spot to be learning computer science. So anyway, that's why I wanted to come to Boston. So when I finished, I kind of stumbled my way through a PhD, you could say, figuring out what it was. And my research and stuff was in graphics and HCI, performance, how to make things run fast, so sort of understanding systems. And these are some of the places I've worked at. So various startups. You're going to notice a little Intel bias, right? So that was there for a little bit. And these are all places where I work or still consult sometimes. And all these places I've worked on various systems things, algorithms, graphics projects, all these sorts of things. So happy to talk about these things as you folks go on your journey and think about your co-ops and whatever. Some of you might land at some of these places. Alrighty, so that's just a little bit about me. And of course I'm a Husky now too. So. Alrighty, so what is this course? That's sort of the first part of this lecture, figuring out what this is all about. Well, here's where it sort of falls. Most folks should have taken 5001 and 5002. I'll talk a little bit about that in the next slide. But we sort of fall in this category here, where we have this sort of very wide course. Right? We're trying to cover some data structure stuff, system stuff, algorithms. So it is going to be pretty wide. It's going to even reach into your next course is 5800 algorithms, and for those who choose to take 5600 the next systems class. So I want to give you a good foundation for those courses, as well as expose you to another few things that you might decide, hey, I want to take a full course on this later in my master's. So that's where we sort of fall. That being said, 5001 is important. We've had folks take 5001 and this class, so if this is your very first programming class, come talk to me. 5001 really is a prerequisite. We'll figure out how to get you adjusted, but typically, hopefully most folks are through 5001 and 2. Or you have prior industry experience or something, but just kind of let me know if that's not the case. All right, so that said, this course though is designed for you folks in a line. Get you through it. I think it's a super fun class. Hopefully it's enlightening. And it's going to be the course that, along with OOD, how many folks are in OOD right now as well? 1,004, so good chunk of folks. So between those two classes, you'll be in the master's and ready to go. Some of you might even be applying for co-ops and those kind of things as well. All right, the goal though for this class is not to intimidate anybody. Again, the topics are going to be new, so everything that's new is challenging at first, but hopefully it's not scary. And if it is for some reason, just come talk to me. That's sort of my goal as an instructor, to make it very comfortable, ask questions. This is going to be a very conversational class, hopefully, for folks. All right, and again, hopefully I get you pumped up for systems. Again, that's my sort of bias, and everybody takes algorithms, and I'll just get you prepared for that. So. All right, so roughly speaking, these are sort of the modules and the different topics that we're going to talk about. So starting with different fundamentals, as somebody mentioned, Dennis Ritchie, so the C programming language, that's what we're going to be using here. We're going to be doing a bunch of things in the terminal. I'll try to justify why I think that's such a critical skill today. We'll talk about processes. What is a processor on your machine? Computer architecture, memory, things that maybe when you're buying a machine, you sort of look at the specs, but now you'll understand why you're getting better performance. Concurrency, so making things run fast or in parallel. And then just some other selected topics, like how to debug. There's going to be an entire lecture dedicated to that, because I think debugging's it's sort of your the best skill you can have. It always gets you out of trouble. For folks who have played Monopoly, it's your get out of free jail card. But for other folks, you just think of it as, it lets you look inside and see exactly what's going on. So we're going to get good at debugging in this class. That's the hope. And then, of course, a select number of algorithms, so sorting algorithms, dynamic programming, greedy algorithms, these sort of different things, and then a whole bunch of data structures. All right. So again, the breadth of the course, you don't have to read this if it's small, is pretty wide. The topics, though, should kind of link together. In the past, folks have said this course is very wide. That is part of the design, just so being transparent, but I think you'll see the link between understanding data structures and how we use those data structures to build algorithms, and then how they're applied in systems. And I think that'll be great. All right. So, computer systems, again, as I said, are they just magic? We turn on our machine. What are the ones and zeros? That's part of what we're going to try to uncover again in this class. Why are things designed the way they are? And you can kind of see. All right, so no more magic. That's our mantra here. All right. So we have to think about some of these things. Somebody at some level, wrote an operating system or is programming, a self-driving car or whatever the application is that might kind of seem mystical. So there must be a way to learn this. And again, that's where we're going here. All right. I'll let you read the comic here too. So Harry Potter the Magician says, in colleague Hermione says, I didn't know Harry spoke Python. Yeah, he's a parser tongue. So. Anyway. All right. So with that said, I want to go ahead and just kind of orient you on the website and just show you the resources. My expectation is today you have no idea who I am. You signed up for 5008. No prep work or anything was required, so let me just, again, help orient you. So how to get started with this course? Well, find my website. It's the same website if you happen to be in John Park, Professor Park's section today for whatever reason. It's the same course, so it doesn't really matter. So just go to teaching. Here we are at the top, 5008. Here's our course. As mentioned, I'm recording all of the lectures, or at least an audio recording. So there'll be a nice playlist here where I just add things. Again, so for whatever reason, if you're absent because of the sickness, which we'll talk about, or just want to review something or hear it, it'll be in this playlist. Okay. And then a week by week sort of breakdown. And the first video actually is just recapping this in like 4 minutes of like, how do I participate in this course? So you can click on this if you miss anything. We have a module that opens up every week here. So this is week 1 where we are, week 2, week 3, etc. I'll usually open these a day before, maybe 2 or 3 days before, so you can read some of the extra resources. Actually, I'll probably make that amendment. And then you can kind of look ahead, see the slides, the readings, those kind of things. But you'll just click begin this module. Here we are. This is where today's recording will go. So if I click on it here, there's nothing right now. But this is where the audio will go. And then there's a couple readings. They say do before class, but it could be before or after, during. These are sort of supplements to just understand what we're talking about. Things that I think might be important. And again, today is day 1, so I would assume you've never looked at this before. All right, the slides, if you want to follow along here, or download them, or write on them, or whatever, are on the right side here. So that's how we get to our slides. So feel free to do whatever with those. And then at the end of class, we'll always have a in-class activity. And this part is graded. It's a small portion of your grade. I'll talk about it. Today I won't let you leave without doing it, but it's just a sort of pre-course survey. So I know a little bit about you, and you can give me some feedback as well. So that'll be that. Let's see, and I'll talk about the rest of the grading stuff. So that's what a module looks like. Let me show you also these other tabs. So there's additional resources sometimes here. And then any code samples that I do or have prepared in the slides, they go in this GitHub repository. So there'll be a bunch here if you want those. Okay, back to the website. So some course information here. I'll click on this tab here. Again, here's all of our sort of logistics, where we are today, who to call, etc. John Park's section. We have a Piazza forum board. I should have added everybody already, so you have access to that. Again, I recommend frequently checking that, or setting up an email reminder or something to check in there. We have Microsoft Teams. That's how I'll be doing most like office hours. I'll be doing them virtually over Teams, at least for the foreseeable future. So we have a Teams link for that, which I'll show you office hours in a moment. And let's see, if for some reason whatever office hours I have don't fit your schedule, just email me and we'll reach out and do something by appointment. Okay, so there is this office hour spreadsheet here. You'll see there's the instructions here. Basically what you're going to do is just go down to the tab here for whatever week we're on. So week 1, you'll find Mike here, and then whoever our TA is, which these will get settled sometime this week or in the next day or two. So find out whoever the person is. This cell here, for example, will be empty, and you'll just say, Mike, and maybe you can tell me, what you want to talk about, Lab 1 or something. Here, I'll make it a little bit bigger here. So that's the idea. We can usually reserve like 2 of these in a row, and then, that's usually enough to fix most problems, I guess, or questions. And that's pretty much it. Don't delete anybody's or create office hours for me at Sunday at midnight or something. I mean, you can, but I might not show up. Don't erase people's names, or I already see people moving around here. We've never had any problems with it, so for now this is working fine. And then
we have used a query website for TA office hours.
No, just this.
Everything.
Yeah. It'll have a link to the right Teams thing. This is FSC, but it'll say 5008. And every TA has their own channel that they click on. So we do everything through Teams. Yep.
We're waiting for these cells to be white.
Correct.
White.
Yes. Yep. Yeah. Meeting with the TAs a little bit later this week, and their first homework assignment for them is to make their cells uncovered whenever they're free. And we have me, John Park, and 9 TAs. So we have a lot of folks. So hopefully that'll be good coverage. If it's not, though, let us know. Then I talk to the department and say, give us more TAs. And that usually is fine. All right, so that's how office hours work. Wow, we got a lot of folks hopping in here. They're ready. All right. Anyway, so that's office hours. I'm going to go back to the course information. And those sort of important links are just at the top of the website, too. So you don't have to dig around. All right, other course information stuff here. So here's all of your TA emails as well, if you need to reach out. Usually what will happen is throughout the duration of the semesters, you might work with someone a little bit more and want to reach out with them to arrange office hours, and that's always fine. The required materials I'll get to in a second. Some folks have already been clicking this button. Everybody will click it today. So a little bit about the course. I think you've read the description at some point, or the registrar description. I'm not going to read that. The objectives and sort of a short answer is we're going to be using the C programming language, learning about data structures, learning about algorithms. I'm a big believer in sort of applied learning, so we're going to be doing a lot more programming in this course. For the algorithms portion, you will be, writing a little bit and proving things and those kind of things, but in an applied way. Course resources. I'll talk about this again a little bit more, but there's a few recommended texts. I think I have the links. All these you can get for free somewhere, so those will be linked here. And they'll usually be linked in either the labs, assignments, or the readings for like what you should be looking at, just to make it organized for you. There's some really cool ones when we get to the algorithms portion. For example, this website, I'm just like, I guess I'll accept that. I'm like learning different data structures visually here. I'll just click on one. So again, I'll point these things out as they pop up. All right, let me get out of this here. I was just going to show you a data structure. But anyway, but you can kind of visualize it. It's pretty cool. Alrighty, so about the course here, again, that's it. And course policies. So just a few general things. And if you're new to Northeastern or just joining us, these will be new. Maybe you've seen some of these other ones. Just some notes on academic integrity, non-discrimination. Never really had any problems with this, but just to say we want this to be a safe space, a fun classroom to visit every week. Again, no stress is always the goal. But we do have various policies. If you run into any of these issues, let me know. Regarding just how you feel you're being treated. Regarding academic integrity, all of the labs and assignments will have a little section that says, hey, who'd you work with? Or did you search Stack Overflow? Like, well, of course. I mean, I searched Stack Overflow. Of course we did. So you kind of like note or annotate that way. So you don't really have to worry about that as long as you just say, hey, I looked at this article, I talked with Mike, whatever. All right. Makeup policies. Again, if we have folks, if you're sick or traveling or, if your brother's getting married, my brother's getting married at the end of the term, so, I understand these things, but if something like that, a major life event's happening, just kind of let me know and we'll work that out. Otherwise, the general makeup policy is you get 3 tokens, which I'll show in a moment, that you can just extend your assignments or lab by a day. You don't have to ask me, you don't have to tell me why. It's usually none of my business anyway, but you just extend your assignment. Maybe you just need an extra day to relax or whatever. That's totally fine. So you get those extensions without asking. If it goes beyond that, every day when your assignment is late, it's just a 10% penalty. Which happens, but again, if it's for something reasonable, just let me know. Alrighty, and I just try to do that mostly to just keep everybody moving along. If something's really putting you off track, then let me know and we'll figure it out. Some accessibility things. We have a resource here, if you're not aware, the Disability Resource Center, the DRC. So again, if you can't hear me or need some other accommodation in class or some way to be comfortable, just please let me know. And you can do that privately or however you'd like. WeCare is another great resource at Northeastern that just helps you with various challenges that you might be having outside of or inside the classroom. I always sort of tell students, and this is sort of part of the wellness policy, I remember being in school, I'm not too far removed from it, and I was, president of the club, I was working a job, I was doing this and that, and things get pretty busy, so, just let me know what's going on and make sure you're well. That's number one important thing. I'll make sure you learn the system stuff, don't worry. All right, let's see what else to say about that. Okay, I'm going to scroll through this, I'm not going to have you read everything. Here's sort of the grade breakdown. This a little bit bigger. How are folks doing in the back? Speaking of, can they see this okay? Folks are nodding along. All right. So we have our little in-class activities, one of those per week, 5% of your grade. We're going to have in-class labs. That includes starting today. That doesn't mean you have to finish today, though. It'll be due next week before you come to class. So my goal is to sort of get you a head start at the end of class. Also to get us be a little bit interactive and kind of moving around. I'm not going to talk at you the whole 3 hours. I can't do that. I have another 3-hour class after this. My voice will die. But labs once a week, and you have a full week to complete them. All right. We'll have some exams, 2 of them. As it stands now, they'll probably, I don't want to say anything because I'm being recorded. Last year what we did is we had them online 10%, open book, open note, not open person. They can't, take it with a buddy. But something of that sort. Again, the emphasis is on this next part, which is the assignments, programming, and sort of doing that sort of work here. Part of that's what I think is important. Part of it's, when I was a student, I took a class where 70% of the grade was an exam. And I don't know. That was stressful. I said, no stress. So here's our sort of rubric. As it stands, I won't make it harder. I won't say, hey, a 99's an A all of a sudden, but this is how it stands. Let's see, some other general things. Because the first day of class, someone asked me once, hey, professor, can you give me an A? And I said, no, you can't. You have to earn it. So let's see. If we have snow days and these kind of things, we'll work it out. There's 2 classes I think I'm going to be traveling, so either Professor Park will be here or those lectures will be recorded. I know we're kind of tired of recordings and these kind of things, but I'll give you plenty of heads up for that. Most likely they'll be recorded, but just in general, we'll keep the show moving. Late policy I talked about. Again, just use the late tokens. That's your first resort. I'll talk about that a little bit in a moment. Let's see. Assignments have to compile, otherwise they don't receive credit. I'll show you the assignments at the end of the class, what I mean by that. Usually we're pretty nice about it, and we'll say, hey, your code didn't compile, and just come visit us at office hours or something. So just keep that in mind. There's no regrades after 1 week, so you can... if I give you a grade, if I give you a 99 and you think you deserve a 100 out of 100 or whatever, you can challenge that, but it has to be within a week of when you get your grade back. It can't be, homework 1 and then you're asking me 14 weeks later at the end of the semester. Because I sort of forget how we graded and how we graded fairly and, where we were lenient or whatever. So that's why we do that policy. It's also just fair to other students. So you can't try to game the system, or try not to. Again, I'm not worried about it, but some other notes. If you're waitlisted, I know we have a few folks visiting who are waitlisted in the class. Just hang tight, come to class, complete the assignments as you normally would, and we'll try to get you in. Canvas I use for grades. That's about it. I might put some supplementary videos and stuff on Canvas, but at least for now, Canvas is just grades. All you have to worry about is the website. Let's see, there's no extra credit assignments, but if you do something really cool on a homework, sometimes we give extra points, so I'm never going to penalize creativity or enthusiasm. Let's see. Alright, coursework completed after the course can't be graded. Let's see, in-class work, again, you have a full week to complete, so just try to get that in, otherwise it's late. Let's see, I have some other policies. No Facebook. I actually don't care so much about that, or cell phones, just as long as you're not distracting someone. Everyone's welcome on their laptops, right? If you want to Google something cool because you just figured out who Andy Grove was, and you're trying to figure out if he was intense or not. Was he a good leader? That's fine. That kind of enthusiasm, go for it. But as long as you're not distracting others, so preferably no video games, unless I'm talking about video games. I don't know. All right. Anyway, last thing here, sort of on the website, and we'll go back to the PowerPoint. Right. Everyone needs to see me in office hours at some point. Now, it's not a strict requirement. I'm not necessarily going to chase you down, but I would like to see everybody. Let's see. There's about 80 folks, so sign up early and often. What I'd like to do is just have a quick meeting with you, even if you have no questions. I want to figure out, what your name is, what your background is, why you're excited about this course or later on, and then it's a chance for you to just ask me whatever questions you want. All right, so make sure you sign up for those. Helps me get to know you folks. Doesn't matter how big the class is, but logistically, it's better for me if not all 80 people come in the last week. You don't have to. I'm not going to force your hand, but it's good practice to just get used to talking to your professors, know where their office is, or virtual. We'll just do it virtually. yeah, and that's about it. Questions on course policy stuff here? Yes. Yeah.
You mentioned that we would be using Canvas for grades.
Yep.
Do we also submit assignments there, or do we use Grades Code?
So this grades will all be done on GitHub Classroom, and I'll explain that sort of at the end. So basically, once you push your code to the GitHub repo, did you folks use GitHub Classroom in 5001 or 2? Okay, well, I'll explain it, and it's I'll do at least one live example today. That's pretty much it. So once your code's pushed up into the web, we have it, and that's it. Yeah. There's a question here. Yeah.
Yeah, so speaking of deadlines, I see that things are due like due January 29th anywhere on Earth. Did you?
Oh, yes, yeah. Yeah, so this is kind of a fun thing here. Some of these deadlines I might align on a little bit of a regular schedule, but let's look at one of the first ones here. So A1, let's see, what's today? Today is the 19th, so on the 29th, I might actually push that to Sunday because I don't, Friday at midnight's kind of hard, and Saturday at midnight's also kind of not fair. Again, I think of things try to think of things from your perspective. But anyway, let's assume this is January 29th, probably the 30th, I'll move it. Anywhere on Earth where it is still January 29th, so that means in Hawaii or some Pacific island somewhere, it's still on time. And if you click on this link here, it'll tell you the last place. So somewhere on Earth it's 7 a.m. So it gives you a little bit more time, I guess. Not that I encourage folks to stay up till it'll be like 8 a.m. or something, but yeah, that just makes it fair, no matter.
We would be judged by Boston time, or like where we are, or like the last place on Earth.
Last place on Earth. Yeah. So regardless, if you happen to be traveling that week or whatever, it'll be the consistent time. Yeah. So you don't have to fly, to Hawaii to buy a supplement. Yes, a question.
There was a reference to a final project in the syllabus. Is there going to be one? Where would it fall within the grading rubric?
Let's see, where's that final project? There is no official final project. The last assignment's a little bit bigger. Let's see here. About the course. Final. I'll look at it or I'll delete it. The last assignment typically is broken up into 2 parts. But yeah, there's nothing of that sort. Yeah, question.
Where are the assignments going to be posted at?
Yeah, they'll be posted on GitHub.com. Before we leave today, I'll show you. Yeah. I'm going to make everybody get the first lab and assignment today. So I'm assuming nobody has those assignments yet. Some folks might have clicked the link here. There's this button here, which we'll click in a few minutes. We'll take a break in a little bit. This is where we'll get all the assignments. Yep. It's going to teach, how many folks have heard of Git or GitHub? Good, maybe half or so. Yeah, so this is a common tool used for sort of posting source code. So along with some of the stuff we're going to learn, I'm going to kind of bring in some tools that you're very likely going to be using in the real world at a job place. So that's why I do it this way, rather than just uploading to Canvas and stuff. Other questions? Yeah.
Is there going to be any offline office hours involved?
Any offline, so in person?
Yeah.
I'm going to leave that. The TAs might have it. I'll let them sort of decide. I'm just going to kind of wait it out these first few weeks. I found for me doing virtual works pretty well when it comes to screen sharing. So I can see your code, since this tends to be a more code-intensive class. Otherwise, I'm sort of leaning over, trying to read your thing, and it's a little bit hard. So that's probably where I'm going to stand, but I'll see what the TAs are fine with, and then it'll be sort of a classic book a room, and we'll have a location we'll put on the spreadsheet. If that's preferable, or you're definitely better learning that way, or more comfortable, and that's not happening, and everybody goes virtual, just post on Piazza. It can be public or private, I don't care. And we'll try to figure out a way to figure it out. Other logistics questions? Yeah?
So it looks like you have most of the time, maybe 9 or 10 days for the assignments.
Yep.
After spring break, it switches to being 2 or 3 days. Is that an accident?
It is, yeah. I'll fix it and adjust, yeah. Yeah, we're not going to pick up that fast. I'm going to look at this. It won't be tonight, but sometime early in the morning, and try to make it a regular. It'll be like every 9 days or something for the assignments, just so you have consistency. Yeah.
How's the lab going to do? Like what's in the lab?
Yeah, so the goal of the labs are going to be to give you a little bit of a push towards what the homework is. The labs are also designed to be the last hour or so of this class. We'll have a in-class lab. So the goal would be if you're, I don't know, if it's a topic you really understand or whatever, you could finish it by the time you leave today. Or it would take you, 2 or 3 hours, a week at most. That's the sort of
So
goal.
what's the 5009?
So 5009, we have to talk about. So 5009, which is happening tomorrow, from 6 to 7:30 if you're in my section, which I think most folks probably have done, is basically going to be there'll be like a 10 or so minute lecture or talk at the start of just something I think is interesting. And then I'm going to take folks' questions or go over the lab, or you can use that time to work on the lab, which we're going to start today. You could think of it, I don't want to call it a super powered office hours with me, but I'll probably start off with, here's something interesting, I wanted to show you this. Any questions about the lab, any questions about the homework, write a bunch of topics here, and then just kind of lead from there. So it'll be a little bit more free form.
You're going to lead the recitation and not the TA?
That's the plan, yeah. Unless I'm doing a bad job, then they'll leave. I am going to see if TAs can join. It will be a more like active. It'll be less of me just standing here talking for 5009. Think of it as just a time to work. Yeah, I'd recommend attending. Yeah. And it will be. I will record those as well.
Are we supposed to use our GitHub accounts for the monorepo or the query one, or does it not matter?
It shouldn't matter. You can use your own. You might have to use your own. I forget the way I set this up, but yeah, it won't matter. Yep. Other questions, comments? I'll move us along to some other stuff. All right, so that's the website, some logistics, our course goals. This one here, yeah, Elephant Room, COVID-19 stuff. So I got a university has set the expectation that we're in person this semester. We're all here. Now some folks are traveling or whatever still. So we need masks. We'll social distance the best I can. This is not the greatest classroom for that. So if you're ever not comfortable or something, let me know. That said, if you're not feeling well, whether it's a common cold or COVID or whatever, feel free to stay home. That's why I'm doing the audio backups. So there's not going to be any penalty for not showing up to class in the sense of like if you're unwell or you just don't feel like it. I shouldn't say that. But I'm not. I don't want to penalize or pressure anyone to like, nothing's going to be graded in class to say. Okay. That's why the in-class activities are now like you get a week to do them as well. Same as the lab. So that's just something to keep in mind. That said, this isn't an online class. These recordings are going to be okay, but sometimes I move away or I draw something on the board. So you might miss out on that a little bit and have to come to office hours or whatever. So I'd encourage you to, be here. I'm going to try to get you to work with your colleagues and start the labs and those kind of things. So the situation is, fluid, as they say here. And hopefully someday we'll get to, some normalcy and these kind of things. Any questions about this? No? All right. If you have any private ones, let me know. And you'll have a chance at the end of the class on the survey to tell me too. All right. Teams. Sometimes I do a little bit of teamwork, and I just might randomly pair you up with folks. And for the most part in the labs, you can work with whoever you want. Why would I randomly pair you up or pre-assign partners instead of just saying everybody find a partner? Anybody have any ideas? Just kind of an idea.
We get used to to like working in teams with people who we don't know.
Yeah, it's going to be like in the real world, right? You can't usually choose. It also helps sort of broaden you, right? You never know. You probably know your roommate's skills if you're trying to partner with them, but you might meet somebody else who teaches you a new way or different things. So just a note on that. Let's see. Course materials we've talked about. Most folks have a laptop. If you don't or are having trouble getting a machine for whatever reason, let me know. We can rent those out. There's a way to do that. The texts, again, here they are just in sort of picture form. Most of these you can get for free, either on Safari or O'Reilly or just the links that I've posted here. Question here and then here. Yeah.
Can you be more specific about how we should be using the design manual?
This one, yeah. I don't have any readings, I guess, directly. I would say, here's a specific. This one, Grokking Algorithms, very good, very readable. I'll usually have like a Grokking Algorithms chapter 3 on the reading list. Algorithm Design Manual shows the algorithms, data structures in C, which might be helpful. It's probably a better book for 5800. So this class and 5800 can serve you. This will be a little bit better with the intuitive, like it's very visual and drawing out. The algorithms are done in Python, which again most folks through 5001 have seen. This will be in C and it's a little bit more formal. And question here, yeah.
You said that a laptop is recommended. Would it be really difficult if we wanted to work between a desktop and a laptop and make that kind of seamless?
Shouldn't matter, no.
Okay.
Yeah.
Like the way it's submitted, like I'm specifically asking like Dropbox, is that something that would work, or are the file structures kind of too complicated? Maybe sync them.
Yeah. So what I'm going to show you how to SSH into the Quarry server.
Okay.
How many folks have done that? Oh, okay, this will be new for most folks. Okay. So it's actually not going to matter what machine you have, even if it's a machine from like 1998 or something, because we're going to be sort of logging into the server and then just running all our code on the server.
Okay.
So if you want to use a desktop or if you have your Mac or whatever, that's totally fine.
Nice. Thank you.
Yep. It doesn't matter if you decide to use a different machine or whatever. That's going to be the power of what we're doing in this course. All right. Let's see. My teaching style, again, I try to make things hands-on. There's going to be lectures. Actually, this is a little bit outdated. This is a little bit of a falsehood. Being an auditory learner or kinesthetic. Does anybody have a background in education or as a teacher? Yeah, it has heard this falsehood. I don't know, yeah. So I should get rid of that. But hey, we're going to learn a lot of different ways. Me talking, us moving around, actually programming, learning. So that said, again, this is going to be mostly hands-on course where we're trying to do stuff. Again, feel free to ask questions as much as you want. I don't really care, and if I have to move things along, I'll move them along. Do ask questions, as I said. My other policy is I'm never going to randomly call on students. I never liked that as a student, so you don't have to worry when you come here, in case you get worried about that. Even when I'm looking around, I'm not ever looking at someone specifically to answer. Don't feel pressure. My one professor once called me out in front of class. He says, I think Mike always knows the answer, but he doesn't talk so much. And he told the entire class, so I felt pressure the whole semester to raise my hand, and I didn't. I don't know, I was stubborn. Let's see. Other fair warnings, these PowerPoints are not good guides if you're building your own PowerPoint presentation, because I write a lot of words on them. That's sort of intentional because, again, you're not going to really remember what I said, or you might mishear me or whatever. So I'll try to be entertaining or active enough to get your attention, but when you look back, hopefully these slides are a good reference. So again, fair warning, I just kind of break the rules there. Again, I'll try to make it, it usually works, and most folks like having detailed slides, as opposed to, for a programming class, having like 3 bullets of jargon doesn't work as well, in my opinion. So we have our teaching assistants. I'll sort of welcome them or ask them to welcome themselves on Piazza. I don't think anybody is here. Looking around, I don't see anybody at least. Email. again, not speaking of walls of text, this is a bad PowerPoint slide, but I prefer Piazza posts over email, especially if you have coding questions, just because I get about 100 a day. It keeps getting bigger, the number. Piazza, though, I will check at like regular intervals, like when I sit down for lunch, or usually when I take the commuter rail home. So I'm usually like, that's a good time for me to bulk email, or not bulk email, but bulk Piazza answer, sorry. Or email, I guess I'm doing both. But so Piazza is greater than email. It also helps because the TAs and everybody else can answer your questions. Me or Professor Park can do that. You can grab me after class or whatever to ask questions. Here's my email so you can get an idea of how fast they come in. Starting at 2 a.m., leave me alone. No, I'm just kidding. Sometimes I don't answer on Saturday too. And on Saturdays you should be, enjoying life as well. Recharge your batteries. Let's see. So again, the expectation is you've taken 5001 and sort of made it through that at least in 5002. So hopefully you have one programming language. Again, if you're transferring in or have some other circumstance, let me know. Maybe you've been a web developer doing JavaScript for a long time. That's fine. In this course, we're going to be using C. We get a little bit of exposure to assembly. We're not really going to do much coding with assembly, but you should know what it is, or I'll explain what it is if you don't. And C is sort of an industry standard language. I'm actually curious, what have folks heard about the C programming language?
Yeah,
It's a pain?
It's fast.
It's fast? Okay, yeah.
It's mid-level.
It's mid-level, yeah. So it's sort of, Python's pretty friendly. It's that's sort of high level. C we would say is low level or mid-level, and assembly is like almost writing ones and zeros to code. Anything else about it? It is fast. That's why we use it. One reason why. It's not going to really hide any details from us. That's the reason we sort of need to use it. It's a natural fit for systems. Once you see how stuff sort of works in here, you'll sort of see it in Python and the abstraction on top. But let me actually just jump to the YC part. It's still relevant. I mean, I just pulled a bunch of jobs. Here's Intel getting commission. No, just kidding. But right, C is still a active language. I think it's the number 2 or 3 most used programming language, depending on what survey you look at. So C skills. Here's some more C skills. Depending on what domain folks want to go into, if you're really excited about hardware or games and graphics or quantitative finance or anything that needs to run fast, you'll probably be using C at some level. Your web browser, Chrome, that's implemented in C and C++, so you can't really escape it. So you sort of get the idea. Now, I've cherry-picked a few examples, but there are lots there if you look for C jobs. So you might like it, and might be the last language you really need to master, I guess. It's a language you can actually master in. It's a small language, I should say. So you can learn most of it in a day. Let's see. Here's what I skipped here. So how to succeed in this course. Starting the homework the day it's released, that even means today, is a good way to succeed in this class. But I don't mean like right after this, oh no, like I have to go start programming. I mean just like taking a look, now that you have the homework, or will have it shortly, just read through the assignment. Just kind of skim it and see what parts seem important, maybe where there's confusion. You can kind of gauge out what's going on. Break up a big task, a homework, into small tasks. Just take a look at it and make that your objective, without looking at it, the day before it's due. I think we all know this, and life happens, but advice, to take. So the same goes with starting and completing your lab early. Again, the lab's usually going to help you in the homework in some way. So doing the lab first, and then the homework's the order of operations for this course. And then the last bullet point is, if you ever spend more than an hour or two, wrestling, trying to get something to work, that's the point where you need to ask for help on Piazza. Don't spin your wheels, all of Sunday night trying to fix something without asking for help at some point. And the answer is it's better to ask more frequently on Piazza than not to ask, or come to office hours more frequently, or whatever. Okay. That's what's expected in this class. All right. So some final words of wisdom. This will become more evident once we start programming here. Write one line of code, save, compile, and then see what happens. Don't write 100 lines of code and then see what happens. Small baby steps. Take big projects and make them small. So these are my words of wisdom from just having taught this a few times and seeing where folks struggle. And I'll try to help you with these skills. All right, let me see where we're at time-wise here. If I log into this machine. Any questions on these few things here? Come on. All right, cool. And we'll figure out what this word compile means too. Maybe we haven't even seen that. All right. So with that said, maybe let's go ahead and it's about 2:30. Let's dive in and actually let's take a quick 5-minute break to stretch your legs or use the restroom or whatever. So it's 2:32. How about 2:38? We'll resume here, and then we'll take one other break later too. There's one called, I think it's Universal. I think it's like the doesn't, don't buy anything. Or maybe create a you should be fine 99%. Hi there.
A question.
Yep.
So I actually skipped 5001.
Okay.
But I took 5004 instead.
Oh, okay.
Should it be okay?
You've done 5004?
Yeah.
Okay, you're fine.
Okay. Because I was curious what was like specifically 5001. That's kind of.
It's mostly I want to make sure this isn't somebody's first programming class.
Okay, so it's just a program.
Yeah. Yeah. So if you've been comfortable in Java and if you know what loops are and for loops and those kind of things.
Oh yeah, sure.
You'll be okay. Yeah. Same question? Okay, yeah, not to scare folks, yeah. Yeah, that's the plan.
Really? Because in my registration, I thought that if I registered the wrong session, because this one says it's online and there's no classroom
Okay.
time.
I guess I would just email your advisor about getting into the section. There's no grade in 5009 or anything, so it doesn't really matter. I don't know. You might just want it on your transcript somewhere that you took it.
Yeah, because this is the one that registered. It says it's online because I didn't see it.
Is that because they're all full or something, or they just don't show up?
Don't show up. And it's okay to put this $5 residence for a session.
Okay.
That's what I do. So I'm really confused.
Yeah. Well, your advisor, if you don't come to a resolution, maybe you just maybe they'll just tell you to do the online one, so it's on your transcript. I don't know.
I guess it's okay. This is not.
Yeah, it's not graded, so it's not going to do anything.
Okay. So the resolution is tomorrow.
Correct. Yeah. 6 to 7:30.
6 to 7 in this classroom.
It's gonna be actually it's not in this classroom, but somewhere else. Maybe I'll send an email reminder out to computer science. Let's see here. Wow, it's going slow.
Bigger than ever.
Yeah. Oh, let's see. Here. 5008, 5009. Shulman Hall, 105.
Okay, sure.
Yeah. That's the one with the Dunkin' Donuts, I think.
Oh!
I think that's the one.
Okay.
Yeah. I'll put that on the website, though.
I have a question. So the deadline for submission, the whole assignment, it's Boston time or the last time?
Let's see. So labs and in class are due right before the next class, so you have 1 week. And then the assignment is anywhere on Earth, whatever that date is.
So even for Boston students.
Yeah. So if you're in Boston and it's if it says due January 29th, that really Boston time is like January
28th.
30th.
Oh yeah, that's true.
Something like that. Yeah.
Yeah.
So you get a little bit more time.
So I can like submit my assignment in 30.
Something like that. It's either
Okay.
8 a.m. or maybe it's 7 a.m. I forget exactly, but whenever in like Hawaii.
I won't do that.
Yeah.
But just make sure.
Yeah, if you want me to say, just look up like what time is it in Hawaii on Google or something. As long as it says at 29.
Oh, so
you're
we
good.
submit our assignment by like GitHub.
Yes.
To,
Yep.
like public.
I'll have a private repository for you.
Okay.
I will help you set that up before you leave today.
Okay.
I'm gonna do
And
that
one more
soon.
question. You mentioned about like the teamwork. Like we have like assignment for team or
Not particularly. Like I might just assign you with some friend to work with on a lab.
So we're gonna like randomize a team that maybe 7 or 8 people as a group.
Yeah, maybe. I mean, I'm not sure. Usually I just do it in pairs. I could do bigger groups.
pairs.
But
Okay.
you'll get
We would do that like in class or for assignment.
usually for like in class, I'll say, hey, find this person. They're your person to work with for today.
Okay.
And you both complete it individually, but you know you have a buddy or
Okay.
you know it's a way to just.
It's kind of in class activity. Okay.
Yeah.
So we're not like giving a lecture for 3 hours, not like that.
Right. Yeah.
Oh,
no.
that would be wonderful.
Yeah.
I can't last that long.
Yeah, no, I can't either.
I can't focus for 3 hours.
Yeah, so for like today it might go a little longer, but by like 4 o'clock or so we're gonna switch to lab mode. Maybe even sooner. And you'll be working on your machine and you'll be walking around or something.
Okay, that would be so good. Thank you, Professor. I'm Chandler, by the way.
Oh, nice to meet you. Here, I'll give you one of these.
Oh yeah, I'm sorry. I forgot the code.
Yeah.
But that's not. I'm from China, but that's not my Chinese name because that's hard to pronounce. So
What's your real names again? Try that.
Jianhua, like Jianhua, like Chihuahua. My last name is Che, so it's, I just try to make it easy for American people. So actually, I prefer you call me Chandler or my real name if you can pronounce. I'm gonna maybe try to go to your office hour, introduce myself again.
Perfect. Yep.
Yeah, I really like your because one of my friends highly recommend you to me. And I'm definitely going to in your class and maybe next semester and whatever you want. You mentioned about 5,000 paid in.
probably be doing, well, there's 50, 100 for algorithms and systems. And the summer, I don't know exactly what I'll be doing, but it'll probably be graphics.
Oh, okay.
Graphics.
Okay. Also, maybe if we want to learn more about graphics, you can have a project.
Yep.
Okay, I got it. Thank you,
So
Professor.
you're welcome. Alrighty, folks, let me start getting us back on track. Alrighty, folks. All right, folks. So we just spent the first half of class or so, not the first half, the first hour, talking about what this course is, going through the website, and these sorts of things here. So what I'd like us to do now is actually to start diving in here a little bit and just see what the C programming language looks like. So we learned it was maybe painful, someone said. I actually don't want to use that word again. I think it's just something that's new and we're going to learn it. I think a lot of folks are actually going to like the C programming language because of how compact it is. And we'll learn sort of how to approach it. It's just another tool. It's a new tool, and we'll try to use it the right way. So that said, I'm going to go ahead and just open up a terminal here. And actually, let me play around with this for just a second here. Let's see if this helps or if this puts folks asleep. Better? Okay, yeah. And let me make one other amendment here. Let's see, big font, biggest. Here we are. This is, just make this kind of reasonable here. Okay. And yeah, biggest font. Okay. Now I'm going to just kind of show you a few different tools, and I want to write our first C program and just show you how this is done. All right, so you're going to see me do a few different things here. I'm going to be using a tool called Vim on the terminal, which is a text editor. Now, for the most part in this semester, I'm just going to be using this tool here. And I'm going to encourage folks, I'm going to sort of push folks to be using these terminal tools, because really this is all a computer is. All the layers on top of it, the fancy graphical user interface, that's just abstraction. But if you can navigate this terminal, you can work on any system anywhere in the world. I think that's a powerful part of programming here. So anyway, let me go ahead and start our Hello C program. Now, I might have written this before. Oh, nope, not. And what does Hello World look like? Well, we have a main function in Hello World. Feel free to follow along, or you can watch however you want to do it. But all of our programs have this main function. This is where C programs start. Okay? And our functions have a return type here where they return integers. So again, this might be something a little bit new versus Python. At the very end, I'll show you a comparison versus Python. But you have to specify, well, what kind of thing are we returning? And in C, we very explicitly say integers here. So return 0 from our main function. And that's sort of a convention here.
How do you start the file again?
Vim, yeah. Yeah, it's not as important, actually. I'm going to release a video. Again, I try to be conscious of how many videos to watch and these kind of things. But I've got an hour and 40-minute C in a day thing that I'm going to release later today. I should say probably tomorrow morning. I'm editing it and it's taking forever, but I wanted to make it nice. But anyway, for our hello world here, now this itself isn't really an interesting program, so we're going to want to bring in some sort of library here. And C has a standard library, so they abbreviate std IO for standard input IO, and .h. .h is the file extension of this file here. And within that file, we have some functions that let us do stuff. So in Python, this was print, for example. If you want to write out some text, that's a standard way of writing output. So in the C language, we have a few of those functions. I'm just going to show you what I think is the simplest one, which is puts here. But if we sort of break it down just a little bit, put, and the S is string. Put string. That's how I read this. And this is to say, hey, put out a string onto my terminal here, or my standard output. Okay. And hello, 5008. And we close the parentheses as you do in other languages. And in C, we use semicolons to terminate or say, okay, we're done with this statement. So folks taking 5004 will get used to semicolons as well, or if you've already taken it, that's how we finish things off. And then I'm just going to save this program here. All right, so you'll see me sort of subtly do it down here every time I hit colon. And then I'll hit W, which is for write or to save a file, and you'll see me save the file here. Yeah, question?
With puts, do you need the escape line? Because I think it's just with printf you need the escape.
Let's see. Let's try it both ways. Let's try it with here. So this is the escape character, \n, which will add a new line and sort of push us down here. So let me run it once like this, and then I'll run it again with that change. Now my question is, though, or what's new about C, and what I want to show you is, we don't just run it. There's actually another step that we have to do here. We have to compile or translate this code into machine code. We do that with a tool called a compiler. And again, we're going to have a whole module dedicated towards how this works. We need some compiler. There's a few to choose from. One's called GCC. There's another one called Clang. It looks like C-lang if you want to remember it as a C language, but you actually pronounce it Clang. So I'm going to try to teach you the vocabulary too, so you sound like a pro. So Clang, and then hello.c. That's this file here that we're compiling, and then the output here, -o. And what do we want to name this program? Right, it's sort of like when you download a program and it shows up on your desktop and you double click it. What's the thing that I double click on? What's that going to be called? That's the executable file. Yeah. And in Linux, we just, there's no extension here. It's just, something like this. You could just label it program or something, prog for short. That's usually what I'm going to be writing. Okay, so just some program. Hit enter. And if it compiled successfully, I should see somewhere this program here. All right, now I can list this. I'm going to show you some terminal commands. That's coming up soon. But actually, let's just run this. How do I run it? // so the dot says look in this current directory for a program, and when I hit enter, it's just going to execute. And voila, hello 5008. So we get our hello, and then the extra new line, and then our prompt again. Okay, so that's sort of the process. Now we wanted to make a change here to our code. So let's go ahead and just remove that n-line character. That was the \n. That's what gave us the extra line here. Oops, let me get rid of it. Now I have to save my code because I've made a change here. And now I have to rerun through this process again. I'm going to go back in here, rerun the Clang compiler because, well, I've got a new text file here, a new piece of source code. I've got to recompile it into machine code and then rerun it as program. And it's a little bit different here, right? There's one less n-line character. fact, let's see if we can actually look at it. Oops. Let's see. There we are. Okay, so you can see the difference here. There's an extra n line here versus this one here. Slightly different here. Okay? So that's the general process with C programming. You make some changes. Again, just a few small changes. Compile your code, run your program. Again, if you're coming straight from Python, right, you just ran Python and then the script, or you just typed in whatever the command was and it just executed. Python was just interpreting or an interpreted language. C is a compiled language, that's why we get all the speed from it. So we're compiling into a special language that the machine understands, and machines really like ones and zeros. Right? They can be very efficient with those. Okay. Questions about this little Hello World program? And I will talk a little bit more. Yeah.
How are you swapping between the editor and then the...
Yeah. So some of this stuff, this is going to be some stuff in the lab and the assignment. I will show you these tools. So this is kind of cool, and maybe the right thing to do right now is just to show it off. Because I will, and I've got a disclaimer about this, I'll send a YouTube video which will actually show what keys I'm pressing as I'm pressing them too. It's might be a little bit easier. But there's cool things you can do, like split the windows into different panes and stuff. And I like this as a programmer because I get a lot of screen real estate here to kind of move around and do different things. All right, so I am going to try to teach you to be efficient here. This is called, for the purpose of a keyword, tmux, which is a terminal multiplexer, sort of multiplying our windows. And I will show you how to use it, at least in YouTube form. Yeah. Other questions about this program? All right. So let me recap it just a little bit. What did we do? Let's see. Well, here's what it looks like. Here's the program we wrote, or something similar to this. Here's how we compiled it with a tool called a compiler. That's what made the source code into something that we can execute or our machine can run. Okay, so Clang, again, is the compiler. Hello.c is our source file. And, we're passing some commands. So we're going to get used to this, right? Instead of double-clicking or moving around our screen, we're passing different commands into our machine. So Clang processes this thing called hello.c, and then -o, that's a lowercase o, output as hello or prog or whatever you want to call your executable. Okay. All right. Now, some other parts of the anatomy that I didn't talk about include here the first line. Again, very similar to if you're coming from Python import. We just include things instead in C. And so we're bringing in some functions like the puts function or put string. Okay. Right. And here's our puts function. We'll look at another one called printf. That's sort of familiar. And that's how we output some code. All right. And then finally, we're done with our program. So main is a function. That's where we always start our programs from. And then we need to return some value. This is just a C special case function. It always returns an integer. 0 by convention means this program executed successfully. Okay. Questions on that? All right. Yes, yeah. Is it compulsory to return a integer number here? Yeah, 0 is actually a convention. There's something you can do that's like this. Now, what if I tried something like this? Let's just return this number. And then if I run it, nothing happens here. Now that said, we can actually retrieve whatever the last value was that this program ran. And maybe it's maybe this number, -236,236, has some meaning. So for example, I don't know, we could have two return statements here. If 1 is less than 0, so something kind of wild like this. I'll show you if statements and return some other value here. So this could have some sort of meaning based off of did the program execute successfully or not. So it's sort of some information. That's all it is. By convention, we're always going to return 0, though. Almost always. For this one, like what is this one returning?
Yeah, I mean like you are declaring the return type in int for the main function.
Oh yeah. Yes, yep. Yeah, so I never, for example, you'll never see me put like some other data type here, like float, or we don't have string, but just as an example, like string or anything like that. It'll always be integer. Yes, yep. Yes. Why can't it be void main? Maybe I'll show you another one. Even if you put void main, which would be fine, it'll turn it into behind the scenes int for you.
The number represent like did it run successfully or like there's an error?
Yep, exactly. Yep. So what it'll do if you put no type, so someone mentioned void, which means like nothing, just no return value. Well, the system's looking for some value, 0, 1, negative 2, 3, 6. It'll behind the scenes turn it into int return 0. All right. And I'll show you how we can inspect that later on. We got to build up a little bit. Anyway, here's what C looks like. And as I mentioned, C is a compiled language, so it's got to go through a few different steps here. So I at least showed you the step where I wrote the code, I compiled the code, and ran the program. This picture, we're actually going to spend 1 or 2 of our modules just understanding this. In fact, most of this class I'm going to teach you in just 3 pictures. That's all you really have to remember. But you'll be able to sort of dive into this and understand what each of the individual steps are. There's something called a compiler, which we talked about a little bit here, or at least we know that's a tool. It does be in 5004 if you've had it this week already. Maybe you've used the Java compiler. There's something called an assembler, which is essentially a readable machine code. Something called the linker, which you'll remember this later. The linker never gets any respect. So we kind of talked about this last part here. And then finally, our program that we're trying to run. Okay, so a bunch of steps, and we're going to dedicate quite a bit of time just understanding this picture here in depth. Just to show you a little bit of what the compiler is actually doing, I'll show you what is going on behind the scenes with something called assembly code here. So this program here, actually, our computer doesn't really understand. Like if I look at my computer and I say, hey, int main puts some string, and I sort of talk to it, it doesn't really understand that language, right? It understands machine code. So we have to sort of lower this language to some other form that it understands. So what that form is assembly. And if we run our compiler, Clang, and this time with this argument -s here, and if I pass in the source file, I'll hit enter. Oops, it's giving me a warning here. And this is to answer your question earlier. It says, well, it changed the return type to int anyway, even if I put void. Actually, let me just change it back here. Int return 0. All right, so let's just get the assembly form of this code here. Okay, vim hello, and then it gave us this file here .s. I'm gonna open it up, and this is what your code actually looks like. Now it's got a bunch of other kind of weird stuff in it. I wonder if we can understand any of this here. Well, actually we probably can. There's something called main. It's a function, and we see this this main thing show up again here. Main. Okay, so that was something familiar. And if I kind of keep scrolling down, I see, oh, there's that puts again. Okay, and it's saying call Q. We got to figure out what that is. We'll figure that out later. But calling something called puts here, and then it's moving around a bunch of data here. Something about moving, maybe adding something. So it's sort of understandable. And then you finally see, hey, there's this string that we wrote in here. Hello 5008. So this is what your actual computer understands. and it'll translate these commands here to ones and zeros, essentially, directly from here. So before we had C language, we wrote code like this. And then we figured out a way using a compiler to translate C code into something that's a little bit lower level here. Okay, so C sort of sits in the middle. So just want to give you a peek at what's going on here. All right. In class, are we going to use this?
No, like there are some classes that like focus on assembly line.
If you take 5600, you'll probably take a little bit deeper dive in this. For folks who are interested in security, maybe that might be your specialty. This is kind of cool when you can see this view because there's nothing hidden here, actually. Or if you're going to do sort of performance, then you can see every little instruction that your machine's going to execute. So there is a reason to actually learn this stuff, even today, even though this is how we programmed 50 years ago. There are still pragmatic reasons. Again, I'm not going to teach you anything that you couldn't use. And a good question often in this class is, but why? Why are we learning this? So anyway, just a little peek at what's going on there. And there's all sorts of other ways that you can sort of peek at the code, which I'm going to move through here. So again, here's a quick view of the assembly, which we just looked at. Just a different view here. And again, it's actually not too scary. We just have to take this thing that looks scary and sort of break it down, right? Look for some familiar parts and strings, the functions that we use, and again, kind of break things down. Question? Yeah.
How can you view the assembly code again?
How can I view it? Yeah, if I use if I compile with this line here, clang, and then -s, and then hello.c. So we did this first, and then it gives me a file with a .s extension, so you can kind of sometimes it's s or it's ASM for assembly. And then just view that source file. Yeah. All right. All right. I'm going to skip. I'll show this tool actually quick here. So another kind of thing to show you. Again, maybe that's motivating and a little bit scary. Let me show you this because it's a little bit scary. Is if I want to compile some program here, like hello.c. There is sort of this intermediate step that happens. So I just say, hey, compiler, compile this here, okay? And the result of that is I get this file. Actually, let me do this a little bit more clearly. If I pass in -c, this just says, hey, just compile this. And if I list out different files in this folder, I have one that's called hello.o here. Okay, so what is that file? Well, that's some sort of machine code, again, that's been compiled, some sort of assembly. And I can actually look at it, and this is true of any executable. So anything that you've ever double-clicked on, to start a program, there's tools. One's called objdump, and I can pass in any of these machine code files, and I can actually look inside of this file here and see what sort of symbols are in here. So for example, there's this function used, main and puts, and you can use this tool to find out other things, like what sort of string is in there. So if you've ever heard this sort of stuff in the news where it's like, Facebook stored a bunch of passwords in plain text, or these kind of things, you can use these tools to just sort of hack and see inside of the code what's going on. So we will look at some of these tools. Again, for folks interested in security, I think this will be super neat to look at. All right, so these are just some of the tools I want to give you a preview that we're going to learn about here. All right, so compilers are pretty neat, in my opinion, I guess. Their job is just to transform something high level that we sort of understand, like the C language, Java, again, for those of you in 5004, into machine code that computers understand. Okay. And again, the assembly stuff's not too bad. We're just going to have to break it down and sort of understand what's going on. But it's definitely better than these guys here. How many folks have like parents or relatives or friends who use punch cards and they give you the punch card story? Yeah. My mom used to program with these. I'm not old enough to give you a punch card story. Yeah, you used to have to punch little holes in here. Depending on the sequence you had, that meant some command. And you feed them into a machine and hopefully not drop them or whatever. Alrighty. Alright, so compilers, they're part of this course. That's sort of picture number 1 down here. 2 other pictures here. So we've got to talk a little bit about, again, peeling the layers back in our systems, computer architecture. This is sort of our next picture here. Sort of a bunch of arrows, a bunch of things going on, but we're going to break this down. And then we'll talk a little bit about operating systems. What's going on there. So maybe starting with the hardware here, we're talking a little bit about the brain of the machine, the CPU, where instructions are executed. And the kind of neat thing is, when we think about CPUs, at least if you just have one, you might have heard these as cores or CPUs on your machine when you buy them. There's actually only one instruction executed at a time. Now, at least that's the model we're going to start with. Right? If you bought a machine, how many people know they have a dual core or quad core computer or maybe a phone that has sort of like 4 brains that can think at once? It can do 4 instructions at a time. All right. So that's the part we're going to start with. And that's sort of this corner here. And then we'll talk a little bit about performance. Again, that's sort of something that I think is important. It's sort of important for you just to understand too when you buy a new machine, and they're asking you for a lot of money, so you want to know, like, are they lying on the specs? Is it just marketing? Whatever. So we need to sort of understand like megahertz and gigahertz and what those terms mean a little bit here. So the magic, number or to actually calculate how fast the machine's working. Right, and then there's a bunch of other devices that we need to talk about. The graphics card, if you want to take graphics with me this summer, we'll do a little bit deeper dive, but we are going to spend quite a bit of time talking about memory. So when you buy a new hard drive, or if you've ever wanted to upgrade your machine and you have these green pieces of memory called RAM, you try to figure those out. We're going to talk about that whole stack. All right. So now taking just a moment to think about operating systems. Right, and here's some examples: Windows, Linux, Mac, Android, iOS, etc. Well, before I dive into it, what is an operating system? What would folks sort of give me as a definition, or if you're explaining it to someone, a non-computer scientist? What's your intuition? Yeah.
It's like the layer between the hardware and the applications.
Okay, that's a layer between hardware and software. Okay, that's a very precise definition. We'll see a figure that shows that. And that sort of makes sense. If anyone's, you buy a machine, right, it'll come installed with Windows or Mac, as I'm looking at most machines. So, it is something that we sort of install, but it's not like a piece of hardware. It's not a device like you plug in a USB. And it wasn't something that you just downloaded from Chrome. So it makes sense that it sort of sits in the middle. Yeah. What else would folks tell me about the operating system?
So the software that other softwares run.
Okay, it's a software that other softwares run on. Okay. Yeah, so it's sort of a manager in a way. If we think about it like a business organization, it runs on Windows. We have a bunch of software running. Or if you open the task manager, you see a bunch of software running. Yeah. That's got to use some management. Anything else? What else, folks? Yeah.
I'd say from a user perspective, it gives sort of a coherence to all the applications. Like if we're used to Windows or we're used to Mac, we're used to finding things in the same places, regardless of the programs for it. They won't necessarily agree with that, but it's kind of this ecosystem for the user.
Yeah, it's an ecosystem. It's organizing. It's got rules for how things are sort of organized, positioned. Graphically, there's certainly an impact, right? When you're on a Windows or a Mac. So it's sort of controlling those things. Yeah. Anything else? Operating systems. Yeah.
Would it be wrong to make an analogy like the brain? Like it's the way it interprets information and acts on it?
Okay, the operating system is the brain, right? We've got the hardware, which is just a chunk of metal, but we need somebody that can control us. Maybe the conductor that's interpreting the instructions. Yeah, I think that's a good analogy. Yeah.
Kind of like a government.
Like a government. Okay, yeah. Yeah, I'll take that as well. It organizes. There's different sort of divisions doing different pieces. Yeah, I think we've touched on all of these and more. How many of you have taken operating systems course now? All right. I usually just, at least when I was first asked this, just thought, okay, Windows, Linux, Mac. Right, and there's a bunch of them, right? Folks have different operating systems on your phone or Windows. Your refrigerator, if you happen to have a smart fridge, has an operating system. Your car, if you have a Tesla, you have a really fancy operating system. If you have a Tesla, I'd love to ride in it, but they're pretty cool. Let's see. So, and they're actively developed, right? They're not just these things, right? You get different versions, Windows 10, 11, a new Mac. So, we've had folks who go on to work on them. But what is it? Well, somebody described it in a picture earlier. You have your user, that's you, your software, and then here's the operating system sitting between the hardware and the software. Okay, so there's sort of this intermediate layer here. Then as other folks said, it's sort of organizing things, giving out resources. It's the conductor. Okay, it's saying, hey, we have this hardware, we have this flash drive, inserted into the machine. And those are our resources available or whatever. So this is the idea here. Okay. So it's a resource manager or allocator. There was a mention of thinking of it like a government. So it attempts to be efficient and fair. Right? How it allocates resources. If I open some program, it's not going to just run only that program forever. Right? There's stuff happening in the background. So it's a control program. That's the conductor. Okay, and hopefully it prevents things like errors and viruses and so on. Right, so here's just an example of where your operating system sits. You could have one user at a time or multiple users, perhaps using different applications on the same operating system, sort of shared. Usually we're just thinking about one person with multiple applications. And then you have your operating system saying, okay, you click the mouse on your text editor, so what's the hardware supposed to do? Is there a mouse plugged in? And it figures that out. All right. Okay, so now what we're going to be doing, again, in our homeworks and our labs, is just using something. You'll hear me call it a few different things, and it means the same thing: a terminal, a command line, or a shell. And that's just the thing that I was typing away on. Right, that was, this. So again, this is all we really need. This is our direct interface to the operating system, in other words. We're saying, hey, what programs do we want to write? What commands do we want to run? Then as we execute them, the operating system communicates that with the hardware. All right, here's our resource manager. So here's task manager if you've ever had to hit, Control-Alt-Delete and kill something. And usually you don't see a program, if your operating system's being well behaved, taking 100% of the CPU, 100% of the memory, 100% of disk, etc. Maybe if you're playing a video game, maybe that's different, or some intense a movie or something. But it tries to be fair, right? Because there's usually multiple things running. All right, and we've got different types of operating system families. So Unix, that's what I'm running on here. So anytime you see me here, this is something called Ubuntu Linux, which might look unfamiliar. I'm going to have most folks try to install it. That'll be part of our lab. Then, of course, there's Windows, so sort of the opposite sides. Mac is more of a POSIX sort of thing. So most Mac users maybe have stumbled into the terminal at some point as well, whether in 5001 or just for fun or to do other tests. All right, so our work environment in this class is going to be in Unix or Linux. So wait, what? So it doesn't matter if you have a Windows machine. It's not going to matter. It doesn't matter if you have a Mac. If you already have a Linux machine, probably nothing will be too new for you. So just a little bit about Linux. It's an open source operating system. It's most been popularized by this person named Linus Torvalds. Maybe we'll talk about it at some point. But generally speaking, as programmers, we like it because it's very hackable. It's a very simple operating system. It doesn't mean it's not powerful, right? We use it commercially all the time. Most folks who go to work sort of on the back end of web development, you're likely to be working on a Linux machine for setting up servers and these kind of things. And it's got a great terminal, which is going to allow us to do more systems-y stuff.
So Mac OS is based on Linux, right?
It is, yeah. It's, Mac is based off of this other thing, a little bit closer, called BSD, which stands for Berkeley something. Berkeley Sockets something, yeah. Development, I don't know what the D stands for. But the Berkeley system, which is sort of Unix-based, yeah. So usually we divide them up in these two sort of families. All right, let me just do a quick time check here. Let's see if I can wake up this PC here. Whoops. 1 second. Oh, it's crashing on me or something. 3:18. Okay. Let me go ahead and just give a little bit of a crash course to the command line interface, showing you some of these commands. And really this is just another program that I'm going to be executing. Again, it sits on top of the operating system, and it's just a really simple program in a sense that you just type commands in and they execute. In fact, for one of your homeworks, you're going to be building your own command line interface. You can customize it, build it however you want, but you'll implement it in C. All right, so some examples here. And I'm just going to kind of run through a few of the popular commands. So let's say I've got a, I guess the way to also do this, let me go ahead and just show you here. Oops. Example. Okay, let me give you a little bit of a mental model here. Okay. So on the right side, this is what we're used to, right? We just have sort of a folder, and then we can click on it. Maybe we right-click and say, new folder, new file. We double-click on things, sort of navigate around. So I'm going to leave that just to the right so you can see what's going on. But we don't need this. This graphical user interface, this is just sort of a convenience for most users. All we really need is this. So where do we start here? Well, let's say we want to make some new file here. So there's various commands. We could use a text editor like Vim. Remember, we created our hello C, and we typed out some stuff here, int main, etc. Return 0, and then I can save that file, and we see it pop up here. Okay. So I'm going to go ahead and close that. If I want to just list the commands here, or the files and folders, ls will do that. And we'll see that, well, I have one file here, which matches, again, here we are. How do I know where I am in the world? Well, I can ask, there's a command for that, pwd. This gives me the current working directory, or the path. So I'm in home/mic/example, which matches here, the top home/example, then my machine mic. That's what it's called. Let's say I want to get out of this directory now. So if I do ls, well, I figure out where I am, pwd, and then I want to go to this directory here. I can change the directory with cd. You can do cd and then type out the path. Mike, something like that. And then check out my path. Here I am. Okay, so now I'm back in here, with all these files of whatever. Okay. Maybe I want to go back to that directory here. So cd, then I can just type, well, from my current location where I am, home/Mike, I can cd. I'm just going to start typing it out, example, and then I'll hit tab, and I'll finish things off and move me into a new directory. So I'm back in here. Okay. I can move to various other directories on my system. So the tilde will be sort of a shortcut from my home directory, which is just here. Let's go into my Dropbox and see what's going on. My academic website, comp, spring 22, and I could sort of just navigate. Here I hit tab, so it showed me all the things that started with spring. I've been teaching for a while in spring, I guess. 22, and etc., etc. And I can list out all the stuff here. Let's go into DS Algo Systems, and again, I'm just navigating around here. I can just change my directory back to home, and I'm back in this path here. So I'm kind of just moving around on the terminal, and this is probably going to take a little bit of practice. You have to build a little bit of a mental model, right? I'm sort of thinking about things just a tiny bit different, right? I sort of have this home location. That's either this tilde mark, which is the curly thing. It's by the one key usually on most keyboards. You hit shift, and then I think it's the key over to the left, and then you hit the tilde mark. That takes you to your home, and then you sort of navigate from there to different locations. Okay, by either typing out the whole location or the rest of the location sort of going forward. Okay. So those are just a few commands. Now, if I was to race somebody and try to figure out how long it would take me to navigate to my Dropbox location, back to here, on the terminal versus doing it with mouse clicks, the terminal is almost always faster. In fact, if we could figure out a way to do this where I can, we can have a race or something in class, that might be fun. But that's one of the reasons to use a terminal. There's nothing getting in the way. Right? If I'm going to do this same task, I have to move my mouse, physically click, move my mouse some distance. I'm wondering if anyone's done any human user experience stuff or research with this. Does anyone know what the law is called? There's a famous sort of law if you've worked in human-computer interaction stuff. And again, I'm giving you some of these tidbits just to get you interested in other courses too. But it's called Fitts Law. So if I have a screen here, and if I have a button here that says, click me, and my cursor, right, I have to move this distance. The further the distance and the smaller the target, the longer it takes you to hit that. So intuitively, that's the idea. Your hand doesn't have to move from mouse to keyboard or any of that stuff. You just do it all in the terminal, you save time, and it's efficient. Okay, so that's at least one motivation maybe you can buy into the terminal. The second is I can use this terminal to log into any machine in the world that has an internet connection. Okay, that's what we're going to do for our homework. Let me just demonstrate it for you now. And what I'm going to go ahead and do is use a program called SSH. So this is a secure shell login program. That's what it stands for. I'll type in my username. I'm going to go to the login.corey.nu.edu. Okay, so this is somewhere on Northeastern's campus, probably in West Village H or something. There's another computer just sitting somewhere. It doesn't have a monitor or whatever, it's just some computer running. But as soon as I hit enter here, it's going to try to establish a connection. I'll type in... most folks will probably have this account. If you don't, we'll have instructions on getting you set up. That's our goal today, to get you set up. So I'll type in my password. You can't see it. It doesn't echo back. I'll hit enter. And you'll notice something changed here. at least two things changed. One, a bunch of text popped up, but my little prompt thing changed. So in this window, everything above this green line says bash, which is a type of shell thing, and this one says Mike. So this is me on my computer here, but in this other window, I'm somewhere else in the world. It could be in California, it could be in West Village H, and now I can use this other machine. So it doesn't matter if my laptop is a $10 machine, but I've used this tool to go into some world-class computer. I have all the power in the world right now, which is kind of cool. So I can, do all of my stuff here. So if I list the contents, you'll see there's a bunch of interesting things, or maybe they're interesting, I don't know. But there's a bunch of different files here. All right, and now I'm in /home Mike Shaw on Corey somewhere else in the world. Okay, and I'll go ahead and exit or leave that machine. Okay, so it's connected to login.corey.nu.edu. It's kind of the same idea as visiting a website somewhere on the web, except you're visiting some other computer in the world, and now you're able to give that computer commands. Okay. So that's what we're going to be doing. That's how you're going to be doing your homework. Everybody has the same environment on the server here, login.corey.nu.edu. Let me pause there for questions on terminal stuff. Questions, comments, things you want to see me try? Yeah.
Who develops these?
Who develops these?
Yeah.
Yeah. So usually, so for example, at you've got a Mac. There will be a team at Apple or something building command line tools. The terminal. These ones are all open source. What I'm typing in here, and I'm literally just there's a program called Terminal here that I just open up. So those are the folks who make them. Ignore all these errors here.
And what would you write them in?
Usually in C. Yeah. So yes, we're learning C. So I can build these. What's also kind of cool is most of the tools. Well, how should I say? Like our compilers and stuff. If you're using Python, maybe you use idle or maybe you use notebooks or these kind of things, right? But you're just kind of like clicking run and those kind of things. The other advantage with this terminal is I can write a script and sort of automate all these commands to just run one at a time. So if there's some task I need to do, we can sort of automate all that, which is really cool, step by step. Let's see. The other advantage of a terminal is the ability to automate tasks. So for example, if I said every day when you turn on your machine, I want you to navigate to the Dropbox folder, copy a file, and move it to some other directory. You could do that, right? You would turn on your machine, move your mouse, double click, open a folder, right click, or do Control-C, Control-V. And here instead what you just do is you'd say, okay, here's a script, and you just one line at a time. I'm going to figure out what my path is, change my directory into Dropbox / folder, copy file 1, make it file 1, copy, move file 1, copy.txt to some location, right? And then I just give you this script, right? I don't have to give you any instructions. I just say double click this thing, and it just sort of goes. So there's a lot of real power in this, right? Maybe this won't be your full-time job, right? Being a professional, just working in the terminal. But regardless of what programming opportunity you pursue, regardless of how technical it is, you can automate something in your job. Yes.
Could I use this SSH thing to access your computer if I knew your password, or are there special ones?
You could. So if I have set up on my machine this SSH sort of server, I could give you my IP address and say, hey, if you type SSH username IP, you could connect to my machine and use this, which is pretty cool.
But you have to set something up first.
I do have to set something up, yeah. And I would hopefully put some security and stuff.
Is the extension for the script file?
Let's see. So I for this one, well, let me just write it. .sh is the convention.
is that how people like hack into the system? Like some like website, like they say download it and then run it?
Yeah, I mean, essentially, right, we've all probably gotten emails that say, hey, you've won something, double click this attachment. And it's usually like a series of commands that are going to run really quick. So I don't know. So don't, anything that's suspicious, don't double click it. It's probably a script like this. Don't send anybody money or crypto or whatever. Alrighty. So I gave a little breakdown here of some different commands. Here they are in the slides, the things that we ran through. Different ways to change the directory. Again, there's some other, so here's just sort of the justification. I love the GUI and so on, but I'm going to teach you a new skill that's going to serve you for your time at Corey and beyond. Especially if you're working remotely, which we've all seen happens. I've had this multiple times. Maybe I'll give you my sort of work stories to say of times I had to log into a machine that was in California, and it was much better to do that than for me to physically fly to California and work. It's cheaper for the company. Okay, so here's just an example shell script here. Okay, so I'll leave it at that. Okay. Okay. And then what we also talked about is this SSH or Secure Shell Login. And that's your tool for logging into the Corey servers. All right. All right. Okay. So are we feeling overwhelmed? Maybe in a sense here. Or you say, Mike, what was that command? LS or PWD or these kind of things? Well, the other really cool thing about the terminal is you can get help directly in the terminal. So let me show you how to do that. I'll open up another terminal here. Get big here. And the way we do this is we just type in man. That's short for manual. And then whatever the command was. So if it was ls, then we see, you'll hear these abbreviated, the man pages, but manual. And then a little bit of help about the command. So ls, what's it do? It lists the directory contents. Then there's all sorts of other neat things you can do with these commands, different arguments or flags. So you can just run ls, or we can do ls with a flag here, and you get sort of different output. This version shows when this file was modified and all that sort of stuff. This just lists all the files, etc. If I do man pwd, print name of current working directory. Okay, so you can type that in any command, and that saves you Google. You don't have to have an internet connection or anything. And again, it's quick. So we'll learn how to be quick. All right, so let's get a little bit into the work environment for this course here. So as I mentioned, we'll be using SSH. You can do everything on the Corey server, so that means it doesn't matter if you have a Windows, Linux, or Mac machine. We've had one person successfully do this course on an iPad and they had a keyboard or something. That's probably not ideal, but that's the power of these tools. Ideally, too, what we'll be doing is installing Linux on your local machine. So for whatever reason the Corey servers are down, there's a power outage, a snowstorm, they're just down because too many folks are working on homework, which happens. We actually have one lab which tends to bring down the Corey servers. It's usually our fault. That's okay. But you'll have a local Linux machine you can work on. Okay. So that'll be part of getting set up here. Let's see. So yeah, a question.
If we already have like Linux-based OS, is there any reason to use Linux specifically?
The environment will be a little bit consistent. There's one homework assignment where things can get a little bit wonky. So for most folks, I imagine, are you on a Mac? Yeah. Most folks with a Mac, 99% of the stuff, you won't have to worry about this. Right? But I think it is good to install Linux. There are some few subtle differences in the tools that we can install. like the debugger that I'm going to be showing folks, GDB, pretty much runs on Linux. It doesn't run nicely on Mac. What was that?
Can you use Homebrew to get GDB on Mac as well?
Okay, yeah, if Homebrew works, I know it causes some problems if you have a new M1 sometimes Mac, or if you don't, maybe or maybe not. I've got solutions for all these things, but it'll make life just a little bit easier since I'll always be showing it. So it's not a strict requirement, but I'll try to, everybody should experience, I think, installing a virtual machine at least once. The other cool thing is when you go into product development and stuff, and you know how to do this, right? You don't have to own a physical Linux machine, a separate Mac one, a separate Windows. You can just launch another entire operating system in this virtual machine. So that's what a virtual machine is. It allows you to emulate or run another operating system within your operating system.
So when you call the terminal has like different colors for the keyboard, that's because you run on Ubuntu?
Yeah, so I'm running on Ubuntu here. I could run a Windows operating system on my machine, but it's running inside of this tool called a virtual machine.
No, yeah, because I run my Mac on a terminal and it's just black and white. The reason that yours has like different colorings, is that because?
Oh, some of that's more just stylistic and probably like I could make mine look sort of like a Mac. You know, the defaults are different though. So I am on Linux versus the Mac ones. Yeah. Let's see here. All right, so here's just an example here, just to make a little bit more clear what a virtual machine. One's called VirtualBox. So this is a Windows machine that's running. And the thing that's here in orange, this is another application that's running a Linux operating system inside of it. Okay, so it's emulating this whole operating system, which is pretty cool here. I think that's pretty neat. It's pretty powerful. All right, and then you can do all the Linux stuff, search for your terminal, and sort of follow along with you know, all the stuff that I'm going to be doing. All right. So here's just sort of an FYI. I've got a little 15-minute video on getting set up with virtual machines. I think I'm showing it on Linux, but this will give you the general idea of how to do it on Mac and Windows machines. If you have a newer M1 Mac and are having problems, just let me know or post on Piazza, and we'll try to resolve that. Let's see. And here's my YouTube disclaimer. So periodically I'm going to show like some FYIs, or this is neat, or here's a supplemental resource. Throughout the semester I'm going to keep adding YouTube videos. I mentioned that I'm working on one tonight. That's taking me forever to edit, but it's going to be sort of a C run through, those kind of things. In general, I like YouTube as a platform for giving folks content. I can see the analytics, so I know, like, I don't know specifically who, but how many students have watched the whole video through, or how many people exited out like after 2 minutes, which is kind of cool. You can dislike it, I guess. I see that. I mean, you're welcome to. I mean, whatever. Keep me honest. You know, playback speed. You can speed it up, slow it down, captions, those kind of things. Last semester I had one complaint out of about 100 students saying they didn't like me using YouTube. So, I mean, just let me know if there's something better to let you, you know, see the stuff here. So, you know, I'm going to give you the full course and all the content, but I like adding to YouTube. I try to make it entertaining and fun. I'm not monetized. I don't get paid extra. I wish I did. But I wish I was a YouTube millionaire, but not yet. Not yet. It costs me money, but one day I'll get monetized and make $1. So, so that's my YouTube disclaimer. Somebody didn't like it when I put these in, and that's fine. Just let me know if there's a better platform. All right. So, speaking of which, I want to show you a YouTube video that's not mine, and then we'll take another break after this. It's about a 6 or 7 minute video, but I think it kind of closes off our systems portion, or a little bit of an introduction to this class. And it hits on what this class is really about, whether we're talking about architecture, operating systems, code and compilers, and so on. It's going to introduce Steve Jobs, the late Steve Jobs, I guess. and one of his engineers. I just want to see what you sort of think about it. It's called the Megahertz Smith. Let's see. So let's go ahead and give me just 1 minute here to click this. Okay. Okay. Settings. Okay, now this is the dangerous first day class volume test. So just bear with me for a second. Make sure it's coming out of HDMI. Yeah, let's start low and then I'll restart it here. Let's see if we have audio in this class. Just bear with me 1 moment here. Let's see. Sorry, I just don't want to blast on anybody. I don't hear anything yet. Let's see. Up there.
Okay, so you just saw.
Come on. Oh, maybe we're not gonna. Okay, I can fix this. Hold on. I'll just do it on this machine here. Actually, that's better for me. I won't get a copyright violation. 1 second. PC. Okay. And let's see here. All right, let me know. Let's see if folks can hear this here.
Against the 1.7 gigahertz Pentium 4. And in the showdown,
Yeah. Can folks start to hear it in the back?
task in 45 seconds, the Pentium 4.
Let me rewind this. Captions. Just gonna turn it up just a little more. All right, so here's Steve Jobs, and they're marketing their new processor. Let's see what we think here.
An 867 megahertz G4 against a 1.7 gigahertz Pentium 4. And in the showdown, the G4 completed the task in 45 seconds. The Pentium 4 took 82 seconds for the same exact task. That means the G4 at this task is 80% faster than a 1.7 gigahertz Pentium. Now I know what you're thinking. How can this be? How can this be? The answer to this question is a technical one, but the name that we've given it is the megahertz myth. And to explain the megahertz myth for us, I've asked John Rubinstein, our Senior Vice President of Hardware at Apple, to come up and give us a brief tutorial on the megahertz myth. John?
Alright, so they're comparing their new processor against Intel processor. That's the context.
Thank you, Steve. Morning, everybody. Okay, so you just saw the G4
beat the Pentium 4. And some of you are thinking to yourselves, wait a minute, 1.8 gigahertz, that's twice as fast as 867 megahertz. And those of you that are thinking this are suffering from belief in the megahertz myth. And that is that megahertz equals performance. But megahertz does not equal performance. It's just a contributing factor to performance. Now, to understand this, we have to look at how processors are designed. There's a lot of complicated trade-offs in processor design, and I've picked 4 of the key architectural trade-offs for us to look at. Of course, there's frequency. We want to run as fast as possible. The frequency will be based on what process we're in and the number of pipeline stages. The more pipeline stages we have, the less work we do every cycle. And so the faster the pipeline can run. These two are very much related. And there's some real downsides to having long pipelines. We're going to talk about that in a minute. Then there's a number of functional units. The more functional units you have, the more parallelism you can have. That's how many instructions you can execute every cycle. And the cache design. Whether you have a level 1, or the size of level 1, the size of level 2, and if you have one, the level 3 cache. So all of these factors play into what the performance of the processor, not just frequency. So let's look at some examples of this. Here are the 4 leading processors in the industry today. The PowerPC G4, my personal favorite, the Pentium 4, Intel's next generation 64-bit architecture, the Itanium, and Sun's latest Spark processor, the UltraSPARC 3. We can compare several characteristics of these processors. We can look at the process, the size, the number of pipeline stages, and how many megahertz they run at.
Oh, pause it just for a second. So again, here's Apple. Megahertz is, again, how many how fast is your CPU? And they're saying, hey, there's only 867 megahertz versus this guy, which is 1800. And then they're comparing all the other features of this piece of hardware.
Now it's interesting, most people would assume that because the Pentium 4 runs at 1.8 gigahertz, that it would be in a much faster process. But the reality is all 4 of these processors are in the same process, give or take. And it's interesting to note that the G4 is a very efficient design, because it's half the size of the other processors. Now let's look at how Intel got to 1.8 gigahertz. They did that to go into 20 pipeline stages. Now we see that the G4 is only 7 pipeline stages. So you're thinking, well, what's a pipeline stage? So all processors execute instructions through their pipeline. This is a very simplified version of it. It's a 4-stage pipeline. Instruction gets fetched, decoded, executes, and the results stored. Now all the processors we're looking at have more pipeline stages than this, and they have one or more of these pipeline stages broken down into multiple pipeline stages. Let's look at an example of this. We have the 7-stage G4 versus the 20-stage Pentium 4 here, and we're going to execute equivalent instruction streams down these pipelines. So, you see instructions flowing down the pipeline, and the short pipeline starts getting results sooner. It takes us a while to fill the longer pipeline. Now we start seeing some results coming off the long pipeline. So right off the bat, the long pipeline has a disadvantage in that it takes longer time to fill. Now every cycle we're executing one instruction and completing it. So you're probably thinking, well, wait a minute, the longer pipeline is running twice as fast as the shorter pipeline. And so at some point in time, it's going to catch up to the short pipeline and pass it. And that would be true in the ideal case. But it's not a perfect world. And there's inefficiencies associated with long pipelines. That's been called in the press lately the pipeline tax. Pipeline tax occurs because there are bubbles in the pipeline that come from data dependencies. That's where one instruction is dependent on the data from a previous instruction. Or even more catastrophic is certain branches can cause the entire pipeline to drain. So let's take a look at this again. Now again, we're going to run the same instruction stream down both of these pipelines. We see that the short instruction pipeline starts generating results first, and you start to see some bubbles. So you see bubbles. Now bubbles can be 1 to maybe clock cycles. Now we see a branch. That's the red instruction. You notice the pipeline drains. Now the instruction gets to the end of the long pipeline, and that one drains. So we see that whenever we hit one of these kind of branches, we pay an enormous penalty for having that long pipeline. Now the short pipeline drains. We see a variety of bubbles, more branches, and we see that the longer pipeline falls farther and farther behind the short pipeline. Okay, there's the last branch on the short pipeline. Finish that last instruction. Continue executing along. There's the final branch for the long pipeline. Now these branches, data dependencies occur very often, right? And it really depends on what your code looks like. Okay, now we'll finish up that last instruction. And we're done on the long pipeline. So let's go back and compare our 4 processors again. Here we have the Pentium 4 running at 1.8 gigahertz, and it goes 20 pipeline stages. It's interesting to look at the Itanium because, again, Intel's next generation processor, they chose to go with 10 pipeline stages. Note that it runs at 800 megahertz. And we see the UltraSpark 3 has 14 pipeline stages and runs at 900 megahertz. So the G4 is an extremely efficient design in that it only has 7 pipeline stages and yet runs at the same speed as other processors that have much longer pipelines. So I hope that this gets you to understand that performance is more than just megahertz. And I hope you're not fooled by the megahertz myth. Thank you, everybody.
All right, thank you. Let's go back to our thing. All right. So, what are folks' thoughts on that? What do they think? I guess, yeah, just some thoughts.
What's the benefit of having a long pipeline then? Because I mean, it's not just you make, out of design a short pipeline. You need a pipeline. So what's the benefit of having a long one?
Yeah, I guess, maybe the analogy we could think of is like, if we're assembling a car or something, sort of think of pipelines in that way. You either have sort of 7 stages and 20 or something. So maybe in the, car assembly or whatever, where you have 20 folks, you have 20 folks working on 20 small tasks very quickly, versus maybe 7 folks who are doing a little bit more work, but there's only 7 to worry about. So that's kind of the fundamental trade-off. And I mean, I guess I don't know which one's better. I mean, Apple is sort of notoriously clever in their marketing. That's always been in their history. Now there is some truth to small versus large pipelines, and I guess that's what this is debating. So I mean, I don't have a direct answer, but that's sort of the analogy to think about. There are some, depending on what types of commands you're running, you want to keep your pipeline and your computer as busy as possible. So why not have a bunch of small stages? And that's where the debate sort of goes back and forth. So, other thoughts? Yeah,
What is the pipeline draining? Why does that happen? Is it like a bad operation causes things to fail? It has to start over?
Yeah.
I didn't quite understand that.
Yeah, that's something we're gonna learn about a little bit. So part of this video is just a teaser of like these terms: fetch, decode, pipeline. But an example could be anywhere in your code where you have an if and an else statement, it's deciding to go one way or the other. And the reality is how our machines get so fast is they sort of try to predict which way they're going to do, or which path that execution is going to take place. And if they do that, then they can start filling up the pipeline. Right? It's sort of like, again, in our car analogy, let's say if you're Tesla, I'll think of a cool company, I guess. And they're trying to predict, hey, we're gonna sell 1,000 cars this year, or whatever. But then, something goes wrong in their pipeline, or they figure out, well, after they made the 50th car, they ran out of red paint, so they can't make cars anymore. They have to pivot some other direction, right? So they get rid of the other 50 cars on the assembly line and essentially start building new ones. That's the idea. So all the work that you sort of pre-fetched, you're branching and saying, no, actually go this way. Get rid of all the old work that you tried to do. Yeah, Other thoughts?
If the G4 is actually playing, why did Apple switch from PowerPC to Intel while
Yeah, that's a good question. I mean, for a while they started building their own chips. In the past, that's right. This G4, all this stuff. Actually, this video is even more relevant today because Apple, for folks who have a newer Mac, have the M1s, right? They're building their own hardware. So part of it for the company is always trying to control the hardware and software stack. So you're not dependent on other, Intel decided to do something different with their architectures that wouldn't benefit Apple as much. That's why some of the changes go. Apple's always sort of been a control your own destiny company. Right? They want to control everything. Right? They want to delete Flash and all these other sort of things. I actually don't have more of an answer. Certainly they're trying to go for efficiency. Sometimes it's also business and sort of strategic. Why support some other open platform that other folks are using? Control your intellectual property instead.
No, but I mean, they made the switch from PowerPC to Intel, I think a generation after.
I think relatively soon after, right? Yeah, Apple was on Intel for a long time. In fact, I imagine a lot of folks have Intels in their Macs right now, until recently. It's always for them about controlling the stack. I imagine. I guess I don't work there, so and they're super secretive. So. Other questions, thoughts about this Smith? I mean, part of it's clever marketing. Part of it's also just touching on, the major theme in this class, which is always going to be about trade-offs. Right? More pipeline stages or less. Right? The application where they're filling in some picture or doing some image processing thing, maybe that's great for their machines, but maybe not for other ones where you're trying to do run a video game or something. So there's trade-offs. Yeah.
Adding a long pipeline, does it influence the size of the chip itself?
Yeah, certainly can. So yeah, theme especially is these days, right? Phones are where most of our chips. I shouldn't say most. I don't have an actual number, but right, the density matters a lot in terms of how much real estate it takes in a device, as well as how much heat it generates, how much power it needs to draw in, which tend to be bigger factors. So yeah, smaller pipeline, maybe smaller size. All right, so a bunch of stuff there for us to think about, and we'll revisit this again after we've learned about pipelines and so on, and see if you have a different view or can appreciate it. All right, we're going to go on another break here shortly, and then we'll transition into sort of lab mode. But before we do, I want to get us our required materials, as promised. So how do we do this? So take out your laptops, phones, whatever you can, and from the website, what I'm going to ask you to do is just go to the actual course page here. Let's see if I can get to it. There we are, 5008. And then required materials, and then you're going to click on this. I guess it's a little bit of an ugly button, but green and orange here. And if you're logged into GitHub already with either a personal account or maybe your Corey one, you'll get an invitation to download the course assignments. And I've already done this. I have to re-accept here. Or I deleted it. I can't remember. I'm going to re-accept my invitation. Click accept. And it might take a few minutes, especially if we all do it at once, but that's okay. But just refresh the page. Usually it's pretty fast. And then you're going to get a link here to GitHub. And then you'll have your assignments. Okay? I'll slow down a little bit because you might need time to actually create an account. So you can create your own free private account or use your Corey one. And once you've done that, we'll take a little break here until about 4:10, and then we'll start talking about C and lab stuff. A question?
Just download the zip. You just download the zip.
I'll actually show you how to clone your repository.
Okay.
Yeah. Yes, sir. Yeah.
Yeah. How much of the course is going to be systems versus operating systems?
It'll be more. I guess it's more skewed towards the start at systemsy stuff, and then there'll be. We won't dive into, maybe at the very end level of time of actually opening an operating system and looking at the code. There'll certainly be times where I show little snippets of like, here's the data structure of the operating system or those kind of things. So it leans more towards, well, I don't know. There's definitely one module where I talk about processes and what the operating system's doing. That's like all OS stuff, I guess.
The reason I'm asking is I looked into Firebase 600, which I told you taken.
Yeah.
And it seems like it's very much OS.
Yes.
Yeah. So I'm curious whether here we'll be covering enough of computer systems.
Yeah, I think so. I mean, the goal is, again, for this course, once you leave, you're ready for the masters. Like by the time you take this, OOD, etc., full bridge. So if you want to take 56 in the summer, you should be good to go. Maybe there's more. I guess it depends on which instructor you take it with. That it could lean more towards OS or other topics, but you'll be fine. Yeah.
In general, would you say that it's more systems than data structures?
At least at the start, for sure. And then about halfway through, we're going to transition more towards algorithms. Part of that's intentional, again, because most folks end up taking 5800 right after this class. So it's fresh in your mind. And we've covered C, so we can do more interesting implementation stuff. So that's sort of the progression.
Yeah. Thank you.
Yeah, you're welcome. Yeah. Hi there.
I had a question about a specific slide where you said the CPU core does one thing at one time.
Yeah, sure.
But I thought that cores have two threads in them.
Yeah, so this is the idea of hyper-threading or some of these things. That is true. Some architectures do. In fact, let me sort of draw a CPU here. We're going to learn it as one thing happening in this pipeline at a time. Right, so that pipeline is to sort of fetch, all those decode, execute, these different pipeline stages. Now there are ways in newer technologies, by new I mean the last 15 years or something, to make this appear as two pipelines, or they've got some other actual physical hardware to make this work, where they can handle two things in their pipeline at a time. And in fact, there is still more parallelism built into here. So depending on what kind of instructions you're using, you might have multiple things that can do just add instructions. So often there is a little bit more parallelism. But as far as just thinking about instructions, there really is just one thing happening at a time. Or you can get to the bottleneck where everything has to wait until one thing executes.
Even among multiple threads?
Even potentially amongst multiple threads.
Okay.
Because the issue is, if we take an example here, let's say we've got a picture like that, picture whatever they were building here. What if two different cores or threads are trying to do something with the same piece of data? He used this word called a data dependency. So if I've got two arrows pointing to the same thing, how do I resolve what order these things go? And the answer is we usually have to pick one to go first and one to follow after. If they both happen at the same time, it's like if two cars are driving in the same intersection, right? Maybe an accident's going to happen, maybe not. So we have to have some sort of order or some way to enforce that one thing happens at once. These are good questions now because there's many layers. Yeah. Yeah, and as you said too, we're eventually going to mention and dive in at least a little bit, what happens if I have multiple cores? What does that exactly mean?
Also, I noticed in the syllabus, networking is written, but then it's working through.
Yeah, it's if we have time. It's a little bit, since the course is already wide, jumping into networking doesn't always make sense. So usually what I do is that's another supplement. I have a bunch of recordings that I did. And I'll talk about it maybe a little bit, just in the sense of I want to give people a little bit of direction if they want to take 5700, the networking course.
Yeah, because I'm not sure if I want to take that course or not.
Yeah, so I'll try to give you a piece of it in some form. If you've taken this one and you want to, there's nothing that we wouldn't learn in here, basically what I covered in the networking is what you learned lecture 1 in the networking class. So from that perspective, it's not necessary in this class, but it can fit if time allows. So yeah, but I will release at some point some networking videos so you can see what's going on.
All right.
Yep. Hi there. Good. How are you doing?
Good. I have a question. So,
sure.
Do you think we should dual boot Linux on Mac like M1, or do you think it would be better to just do a virtual machine?
If you can get a virtual machine up and running, that's pretty easy.
Okay.
If you wanted to dual boot, I think that's fine too.
Yeah.
If you have enough memory available and those kind of things. I think either is fine. Try the virtual machine first, and if it doesn't work or gives you problems, and dual booting is easy or it's something you've done before, that's totally fine.
Yeah, it's something I was willing to try, I guess.
Yeah.
Okay.
It's something worth doing, I think.
Okay.
Yeah.
Sounds good. Thank
Cool.
you.
You're welcome. Alrighty, folks, let me get us back in action here. So we got about 45 minutes, and we're going to sort of transition to the lab mode, and I'm going to help you get started with how to get your assignments, work with GitHub a little bit. And then for tomorrow, the actual recitation or 5009, we'll jump into a little bit more C programming stuff, which will be part of your lab as well. But let's go ahead and take a peek here. So I'm going to hop through some of the C basic stuff. We'll see this again tomorrow. Dennis Ritchie, as was mentioned earlier. But I want to go ahead and get us started with just the lab stuff. So as mentioned, usually the last hour or so of class, it'll range between 45 minutes today to an hour and a half or however long. We'll work on our lab stuff. I'll try to have some of the TAs also attend this portion as well, but we'll get a chance to work together here. So, how do we start here? Well, we've acquired the monorepo, hopefully by clicking the link. If you haven't gotten it, speak to me at some point here. I'll help folks sort of individually in a second. But we're going to want to work on the Cori servers, and that means get our repository on the Cori servers. Now, there's two reasons to do this, two key ones. One, it gives everybody a Linux environment to work on, and that way you can work from anywhere. So whether it's your machine, your friends, or whatever, you can log into Cori from anywhere in the world and work on your GitHub code. The second reason is that Cori servers also make hourly, daily, weekly backups too. So if you ever are afraid of losing your code or these kind of things, you also have backups, which is the purpose of Git, which I'll talk about anyway. But you have double backups. Okay, so how do we do this? Well, let me show you how on my machine, and then I'll talk about doing it on Windows, Linux, and Mac by showing you on the lab here. Okay, and let me go ahead into our repository to start. So every week you're going to get a new lab and assignment as mentioned here. And those are going to show up in your repository. Now, in order to start working on here, this is github.com, which just hosts a bunch of files here. But we want to actually work on or figure out how to get these folders onto our machine. So what we're going to do, and feel free to follow along here, I'm going to work through this slowly, is you'll click on this green button here for your code. And you'll see this option here for clone, and this is how we're going to clone or grab all these files and bring them onto our machine. Okay, so I'm going to hit this button here, which copies this link, or you can double click it and right click and do copy here. And you're going to have your link. It's going to be something github.com, the course name, monorepo hyphen whatever your username is. Okay. And then what I'm going to do is open up a terminal window here. And maybe I'll show you. Now, if you're on Windows and you're saying, hey, I don't have a terminal, let me go back to the slide here. There's actually this program here called PuTTY that you can download. It'll be the same sort of instructions, but this is how you can get a terminal window. If folks have the Linux subsystem on Windows, you can also use that. But PuTTY is also fine. Okay. So what I'm going to do is, first I want to work on the server. So that's going to be SSH, my name, at login.cori.neu.edu. Okay. This is your Cori account. Yeah, great question. So that answers two questions. One, what is this name here? This is your Cori login. So for folks who used Bottlenose or maybe Gradescope, I think that's probably the username. Office hours as well? Yes, thank you. Yeah. If you don't have a Cori account, maybe you're joining us or whatever, in the documentation here, let's see. Let me click on monorepo FAQ here. And under these directions, somewhere here there is a link that says, how do I get an account? In fact, it's at the very bottom here. Creating a Cori account if you need one. Let me show that again. So from your monorepo, scroll down, monorepo FAQ, and then your Cori account if you need to create one. If you're not sure if you have one, you can use the second link to look it up. See if you have it. So again, your office hour link, Bottlenose, any of those tools. All right. So once I've done that and used my Corey password, which let me type that in here, it's not going to echo back. And I'll hit enter, and then you should see some different prompts here. And it'll say something about a Linux machine, and maybe give you a warning here about some different things to do. Okay. Okay. So once you see this, you're officially on Corey. Okay. You're working on some other machine in the world. And then this is where we're going to want to clone our repository. Okay, so let me actually I'm going to bring up that link here. Here was the link. And we go ahead and bring this here. So the command that we're going to do, again, git clone, and I'll just type out the repository. You can copy and paste it in most of the time. HTTPS github.com/spring22 ds algo sys. Make it a little bit longer for you here. monorepo-mikeshaw.git. Yeah, you can just copy it, and I just typed it. Yeah, question? Did it? Okay. Let me try this and see if it works, and then I'll look at the personal access token and then show. Oops, it already exists. RF. Okay, clone. All right, and then it's going to ask you for your username and your password, your GitHub password. Now, somebody noted if you type in your password, actually, let me type in mine. You might get this error here, where it says support for personal authentication was removed, yada yada yada, and you need to create a personal access token here. All right. Did anybody else get this message that they used to GitHub? Yeah. Okay. That's okay. Another question here, and then we'll resolve this. Yeah.
If you do the SSH thing and it says something about keeping the authenticity of host long can't be established.
Let's say yes.
Yes. Yep. Yeah. It's safe. We promise it's safe. Yeah. So yeah, when you're SSHing, if it gives you a message about like a yes or no, do you trust Corey server? In general, we trust Corey College. So that's fine. All right. So if you get this message by putting in your GitHub username, well, we just need to follow this link here. What you do for that, it's a little bit annoying actually, is you go into your GitHub, your settings. Let's see here. I've actually got to remember. And I think it's this link. I can't click it because I'm being recorded. Oh, developer settings. Okay. Developer settings. Down here. And you'll create a personal access token. And you want it's going to have a bunch of options that say like read, write, modify, or those kind of things. You want to. This is the actions that you're giving yourself. Okay. What you're going to end up with. And let me sort of write an example here, is you're going to create this access token, and it's going to have a bunch of characters. It's going to look something like this as your like password. Whoops. So the easiest way, once you create that token, is going to be just to copy whatever that token is and use that as your password. There's a way to set it up so you don't have to type this out every time. That I'm going to defer to Piazza. And you can just sort of search how not to type my personal access token every time. Basically, you just save it and trust it. Yeah, question?
Should we enable all the scopes?
Yeah, that's fine for this. Yep. Yeah, so it's going to have all the scopes, or it's going to say like read and write access or something like that. Just check them all off. Yep.
said this is a little online instructions. I got studied the very first piece, the SSH.
SSH.
Yeah, I couldn't get a response from the server. If I was unknown.
Okay, and you did, let me write it out here. Let's see. So let's see, it was username, at login, .Corey. Try to do that, make sure it was that. Yeah, on the slide. So the very first thing that's going to have the SSH server, which you'll just type out this part. That's actually all you need to do. Then you just okay, and it'll prompt you for your username and password. Let's see. Resume. Alright, so the first lab is going to help us. I mean, that was a few steps I showed. That's the same stuff I do in the 4-minute course logistics, so you'll see it again. And it's the same stuff we're going to do on our lab, essentially. It's just written out. So there's a couple different small parts to this lab here. And we have also tomorrow to sort of walk through some of these instructions as well. So the prompt for our lab is actually based off of an interview question I had at LinkedIn about 10 years ago or so, before they were bought out by Microsoft. And they asked me, Mike, name 10 terminal commands. Luckily, I'd been using the terminal, and I named 10 commands. So the challenge for this first lab is going to be use 10 different terminal commands. That's going to be part of it. Okay, so we're going to get a little bit of terminal practice. Now this lab, again, because I see people sort of scratching their heads or still trying to figure out or talk about how to get it working, there's another video tutorial here showing you essentially how to complete all the steps of Lab 1. Because it's important enough, right? I'm throwing a bunch of tools at you. Terminal, Git, etc., etc. That said, it's still worth getting started, tonight, tomorrow, before recitation, so you can ask questions. Okay, so looking at the different parts here, part 0 is, well, first make sure you have access to this repo, which hopefully you do. And if you need a little bit of help with GitHub, take a look at some of these guides here. All right. Now, some other resources to keep an eye out for. Let me grab the website. On our Module 1, again, couple videos here. So there is a Git beginner's guide here. There is a little, what is SSH, and so on. Okay, so a few resources here on our readings as well. The next part, again, describes each of the steps for SSHing, like I was showing, and how to clone your repository. Again, just sort of written out in part 1 here. Okay, what exactly is git commit doing? Okay, and there's a little bit of documentation and these different commands here. All right, then once you've cloned your repository, then it gets into the at least 10 commands that I want you to learn on the terminal and get used to practicing. Okay? And just some other tips on how to navigate the terminal quickly. Okay, so a few different ideas here, a few different resources. Part 3 is going to be a little intro to C programming. Again, I'm going to help with that with another video here, but this is just a little interactive tutorial here. So we don't have to worry about compilers as much and so on here. Because there's just little exercises, and you can click the little start exercise button, and it brings up a prompt at the bottom just to try typing in some code. So a few examples to look through there for part 3. And then part 4 is some instructions on setting up a virtual machine. Okay, if you want the Linux environment. So, a few notes, because it's a lot of different tools. Right, it's Git. It's using, maybe some text editor and a terminal, running some terminal commands, etc., etc. Right, so maybe a little bit overwhelming to start. What I would like you to think about doing, I try to get everybody on SSH, is if you're still running into problems with connecting to Cori, you could do a git clone on your local machine too. That's fine to just start with. Eventually we'll want to get you on Cori and running and so on, but I want to make sure you can make some progress forward. That's one of the sort of powers of Git. You can clone your same code base on multiple machines, whether it's in Cori, locally, whether it's on your friends, and it's the same code everywhere. Okay? As long as you git, add, commit, and push, then you can retrieve the same code from no matter what machine or where you're working. Does that make sense to folks, that idea? Okay. Pause for questions on the lab material. Yes, yeah.
What was the level of access you were in the scope of the token?
Just everything.
Okay.
Yep. Yeah. Another question?
So I figured it out, but it might be helpful for other people.
Sure.
If you're in the SSH in your virtual machine and you'd like to be out of it, it's just typing exit and hitting reject.
Yes. Yeah. Perfect. Yeah. Yeah. Once we're done, exiting is polite too. Otherwise, you're just kind of hanging out there in limbo. Other questions on logistics, the lab, what's going on?
Like this assignment, what we have to do is, what's the instructions or what?
The question on the assignment has come up. I showed lab 1, I didn't show assignment 1. Assignment 1 has to do a little bit more with C, which I'll talk a little bit more about tomorrow, kind of give an introduction. Let me go ahead and just bring it up here. But very briefly, what you're going to be doing in assignment 1, folks in the front, listen up, is build a little guessing game. So this will get you a little bit used to C programming, writing loops, how to generate random numbers, and so on. So there's a little bit of a description. It's basically just to compile and write your first C program. You'll be doing a little bit of that in Lab 1 as well. This one's just a little bit more substantial. Yeah. All right. Other questions? Yes?
So after making the changes, you're supposed to commit and push, right?
Yes, correct. Yep. Git add, git commit, git push. Yep. Question here?
What's the difference between add and commit?
Yeah. So add is saying, hey, I'm getting ready to save this file. I'll send out in one of those like 15-minute guides that sort of talks a little bit about the difference. Let me see if I can just draw a quick picture.
I watched the videos and I read all the stuff. It's just that it's not clear to me. You want to track your history of the files.
Yep.
When you click add and when you don't click add but you don't commit and you modify the file, what happens?
Whenever you do, you always do git add before you commit something. And that's sort of saying, hey, I'm getting ready to save some block of data.
They're always there.
Yes,
Like if you
essentially.
add is commit, then it's correct. You don't leave your add without commit.
Right, yeah. In general, that's for this class, that's always using that parameter. Yep. Yeah. Other questions? Comments? Right. All right. Let me sort of let folks loose for the last 10 minutes. I'll kind of hang out up here for other questions. You can kind of work alongside wherever you left off in the process. We'll pick up part of this tomorrow too if you are struggling with Git or whatever. And then the game plan is to talk a little bit about C tomorrow and a little bit more about assignment 1, just so you have a head start on that. Sound good to folks? All right, I'll kind of hang out here if you have like a sort of one-off question or about getting set up or whatever. And we'll see you soon. Yeah, come on up.
Sir, I'm trying to bring.
Oh, 1 second.
I'm sorry.
Yeah.